your mains examination. Maximum 2.5 months. Well, effectively you get 2.5 months. The duration can be 3 months, right? So I just wanted to make one point very clear that this geography optional is going to be the last optional batch before the completion of next cycle of examination, because I'm not going to take optional classes after notification. Are you getting my point? Okay. Okay. So I would say this information has to be very clear, because I don't think I would be able to justify. I don't know about other options, whether they can be managed or not. But as far as geography is concerned, no, that is not possible in 2.5 months, right? Okay. And then we have engagement in GS papers also, and that would be a kind of crash course, right? I mean, 20 days maximum to one paper, and this is how we have to complete. So the second generalization which I can make out from that particular situation is that you people are very lucky, right? Because you have joined advanced optional batch. That means public administration ho ya fir geography ho, koi bhi optional ho, right? So you are attending advanced batch, and you'll have enough time to prepare for your optional subject after the declaration of notification. Okay. So this is one important thing I wanted to share with you. I mean, just randomly it came into mind, and I concluded this with utmost responsibility that I won't be able to take geography optional after the declaration of DT result. That means till the completion of next cycle, and I don't know when the next cycle will be completed. Maybe in 2025. Yes or no? So this is one information I wanted to share with you. That just a thought in my mind. Second, like you are saying, my classes are being recorded. Okay. So this recording, this provision of recording will continue till this Saturday, right? After this Saturday, there will be no recording, right? And this is just to ensure that those of our friends who are willing to join, but they are late and they will be joining after 1 week, 10 days. So keeping in mind that those candidates should not miss any of the classes, right? I have ensured that we have a unprofessional way of recording unprofessional, okay? Because that is very irritating, right? So that is right. That provision has been kept keeping in mind the interest of the students who are joining us late, and I don't want them to miss anything. Okay. So this is one activity, I would say one continuing provision till Saturday, and after Saturday, that means from next week, right? From next week we'll have no recording. Okay. So whatever recording we have for the classes till Saturday, that would be shared in the group, right? The link would be shared. I think the link of first class was shared in the group, but other videos are yet to be uploaded in YouTube, right? And I'm not a specialist, right? Everything is done by Amritanshu sir, so he would be dealing with that. Once that is done, I would be sharing the link. Okay. So don't be patient, especially those who have attended the classes. They have no need for the video. Yes or no? They have seen everything live. Okay. But still you won't, if you don't trust your memory, right? If you have a very short-term memory, and you feel that my memory has vanished away. Who took my first class, second class, third class? What happened in first 3 days? So for those people, you have that provision, right? So and you can revive your memory by seeing the video. Okay, fine. Now coming back to the business, and yesterday we dealt with the background of the first topic. That means we are now into geomorphology, and then we have to deal with the first topic, that is origin and evolution of the earth crust. And origin and evolution of earth crust cannot be treated or cannot be discussed in isolation. That must be related to the processes of origin and evolution that was taking place inside the earth itself, right? So earth crust, you all know, is one component of the earth interior, just one layer of the earth interior, the outermost layer of the earth interior, that is your earth crust, right? So when we deal with origin and evolution of earth crust, we have to also keep in mind the theories which have been given to understand the origin and evolution of the earth, right? Many theories we studied, right? We talked about the early concept, nebular hypothesis, gaseous hypothesis, we talked about binary star concept, we talked about tidal hypothesis. Yes or no? But these all earthly concepts are no more, right? No more valid, right? Which is the concept we rely upon in understanding the origin and evolution of the Earth, right? Earth and the solar system, that is your Big Bang hypothesis, right? So we'll rely upon Big Bang hypothesis, whatever we have understood, and then, right, then we are going to apply that in understanding the origin and evolution of, right? Origin and evolution of the Earth crust. Okay, this is what we are going to do. So now the stage for the topic, that means the stage for the first topic of geomorphology is set. We don't have to look for the background now. We know the background. We can directly now deal with the origin and evolution of the Earth crust. After that, we'll take into I would say we'll include the next topic. That means we'll take into process the next topic after dealing with this, and that would be our physical condition prevailing inside the Earth. Okay. So this is how the topics have been arranged. You already have the index of those topics, so I don't have to repeat that time and again, because that index is very important, right? If you know the sequence of the body, right? If you know how the organs of the body are arranged, so it would be easy for you to take a synoptic view of the entire body. Okay. So let us start with this. Origin and evolution of Earth crust. This is the first topic we have in geomorphology. You all have seen the syllabus. Okay. Now, origin and evolution of Earth crust has two parts. First of all, let me highlight this. Origin, right? Origin means the events that has led to the development or evolution of or you can say that has led to the origin of the Earth crust, and evolution means the processes, right? That means a long running process, the process which has continued for millions and millions of years, and that has led to the transformation, right? That has led to the transformation of the Earth crust. So origin basically talks about, obviously it is not a one-time event, right? But origin basically talks about the development, whereas evolution talks about the sequential process, right? The sequential process of transformation of the characteristics of Earth crust. So when we study the origin and evolution of Earth crust, we have to divide the topic into two parts. One dealing with origin, the other dealing with evolution, right? Then the third point which I want to highlight here is your Earth crust, right? You know that Earth crust has two parts. Okay, this Earth crust has two parts. One is your continental crust, and the other is oceanic crust. Fine. The point which we have to keep in mind is that continental crusts are lighter, right? They are lighter in nature. They are made up of sialic material, whereas the oceanic crusts are denser. They are made up of basaltic material, right? So continental crusts are granitic in nature, made up of sialic material, and you know that granitic rocks are having higher percentage of silica, right? Whereas oceanic crusts are basaltic. They are made up of denser material. I said they are made up of denser material. So this is one point you should keep in mind. We'll talk about other differences, right? But the first thing which you have to keep in mind is that continental crusts are made up of lighter substances, so they are lighter in nature, and the oceanic crusts are made up of denser substances, so they are denser in nature, right? Okay. So this is what we have to study. That means when we talk about Earth crust, we have to take into account two components of the Earth crust. One is continental crust, that is your land mass, and the other is your water body. That means the oceanic crust upon which we have water, water body is resting. Okay. So this is what we have to study: continental crust and oceanic crust. How the oceanic crust have evolved and how the continental crust have evolved. Okay. Now to deal with this origin and evolution part, we have to take into account two aspects. There are two aspects or two dimensions of this process for evolution of the Earth crust, and these two aspects are basically divided into external aspects, and the second one is internal aspects. Now, external aspects include three important events. One, that is your degassing, which was related to the processes involved inside the earth. So we'll talk about this. I'm just giving you structure first of all. Okay. Coffee. Thank you. Okay. Now come to the next one. Second is the origin and evolution of secondary atmosphere. And when I say secondary atmosphere, the primitive atmosphere, the original atmosphere of the earth was lost forever. So secondary atmosphere came into existence after this process of degassing. Okay. And third was the event related to again external factor, and that is your meteoritic bombardments. That means meteorites hitting the earth. Okay. Many of those meteorites they bombarded the earth. So these were the external events, or I would say those external processes that was involved in the origin and evolution of the earth crust. Now, internal aspect. What are the internal aspect? Internal aspect deals with the processes involved in the transformation of earth from gases to liquid state and liquid to the solid state. Right? So the first thing which you have to keep in mind is what the processes taking place inside the earth and that led to the transformation of earth interior. Right? That led to the transformation of earth interior from gaseous state to the liquid state and finally to the solid state. Okay? What are the processes? Those processes are density differentiation, that takes place in the gaseous state, and the second process was magnetic differentiation. That takes place in liquid state. You can call it as chemical differentiation also, right? So magnetic differentiation or chemical differentiation that took place in the liquid state. Okay. So these are the processes involved in the origin and the evolution of the earth crust. So there are two aspects of those processes. There are two zone of those events taking place. The first zone is internal processes, internal events, and the other is external aspect, or you can say the zone where we had other processes taking place, but that was beyond the earth interior, right? Beyond the earth interior. So that is your external and internal aspect. For a moment, we'll not talk about the external part, right? I said I'll keep that external aspect, right? I'll keep that external aspect at bay for some time, right? After we complete the internal aspect, that means the processes which took place inside the earth, then we'll go to the external aspect only when we have the formation of primitive crust, right? Once the primitive crust is formed, then I'll talk about meteoritic bombardment, right? once that primitive crust is again being recycled, ruptured, right, deformation is taking place, you have churning of the material is again going on inside the earth, and then I'll talk about these two, right, these two, I would say event, one is your degassing and the other is your origin and evolution of, the secondary atmosphere. Now, right, one more thing you should keep in mind, that granitic rocks cannot be formed. I said granitic rocks cannot be formed unless until the magma, the superheated magma, comes in contact with large amount of water, right? I said large amount of water, and to assume that there was large amount of water, there has to be heavy rainfall, right? And for rainfall to take place, there has to be one atmosphere, where clouds will be formed, right? So this is what we are going to see. That means unless until we complete the discussion on basaltic, right, basaltic layer. That means once we have understood the formation of basaltic crust, that means the oceanic crust, then only we will involve the origin and evolution of the secondary atmosphere to understand the event that led to 40,000 years of continuous heavy rainfall, and that led to the creation of water body on the surface of Earth. And the magma was still was being recycled in the form of those convective current. When that magma came in contact with the water body, you know what happened? A part of the magma again underwent magnetic differentiation. The lighter one separated from the denser one, and the lighter one which came above the sea level became the continental nuclei, right? They became the land pieces, small pieces of land, because I told you very clearly that there was no land area, right? There was no land area initially. There was only one type of crust, and that was the oceanic crust, right? That was the oceanic crust, and that oceanic crust has been recycled. It is still undergoing recycling. So no, because you know that oceanic plate, when it comes in contact with any other plate, right? Be it your oceanic plate or continental plate, one of the oceanic plate is going to subduct, right? The heavier one will subduct, and ultimately what will happen? Once that plate undergoes subduction, it will undergo melting, right? Melting will lead to formation of magma, and again that magma will erupt, right? Again that magma will erupt, and that will lead to what? That will lead to either formation of a new crust, or that will lead to formation of volcanic island. These are the landforms we see, right? We see being formed under the process of magmatic intrusion, right? So these are the external events. We deal with that after we complete internal events, right? So let us start with this internal aspect of Earth interior, and see how those processes and events took place that led to the origin and evolution of the Earth crust. Now you see this one. This is the first stage, right? That means the Earth, right? The Earth is in gaseous state. Earth is a nebula, okay? Earth is a nebula, right? And then, right? And I said, and what happened with with continuing process of what? Cooling, right? Continuing process of condensation. What happened? The size of the nebula started decreasing. I said the size of the nebula started decreasing. The nebula underwent contraction, and ultimately compression and contraction of the nebula led to increase in the density of the nebula, right? The nebula started witnessing increase in its density, right? And with increasing density, what happens to the nebula now? The interior part of the nebula has become more and more hot, right? That means the temperature inside the nebula is increasing, and you have what? Density differences are taking place now. That means the lighter material is now separating from lighter elements are now separating from the denser one, right? And under this process, what is happening? The denser material is proceeding toward the Earth interior, and the lighter material is thrown outside the Earth, right? That means toward the outer part of the Earth, right? That means outer part of the nebula. So degassing is going on here, right? Degassing is going on. But degassing is not an important activity here now, because the gases are being released, right? Those are the gases like you have nitrogen, you have carbon dioxide, you have methane, right? These gases are released now. Okay, these gases are released now. But the gases are escaping the gravitational field of the Earth. Why? Because the Earth is volatile. Earth is volatile. It has weak gravitational field. Weak gravitational field, right? The gravitational pull of the Earth is very weak, okay? And because of that, what you have this nebula, nebula having a thin layer, a primitive, a thin layer of gas. That primitive atmosphere, this is your primitive atmosphere, right? This is your primitive atmosphere, which is lying along with the nebula, right? This primitive atmosphere is now being subjected to what? This primitive atmosphere is subjected to two events. One, solar winds. Solar winds swept away the primitive atmosphere of Earth. Right? So solar winds were very strong, right? And Earth was having a weak gravitational field, so it was not able to hold. It was not able to hold that primitive atmosphere, and primitive atmosphere was lost forever. Lost forever. So two things you have to keep in mind here. Why primitive atmosphere was lost? Primitive atmosphere was lost because of two factors: strong solar winds. Solar winds are still very strong, yes or no? But they are not able to remove the atmosphere from the Earth. Why? Because this atmosphere is now pulled by, that is attached by the strong gravitational field of the Earth. The Earth was in a gaseous state. It was very volatile. It had weak gravitational pull, so it could not hold the primitive atmosphere, and that primitive atmosphere was lost forever. Right? Earth lost this. Right? Now comes the second stage. When you have this primitive atmosphere being lost, what is left now? The left part is nebula only. Right? That is a nebula only, right? And this nebula is undergoing what? This nebula is undergoing density differentiation. Density differentiation. I said to you very clearly, the density differentiation takes place, right? Density differentiation takes place in the gaseous state, right? So denser elements were proceeding toward the center of the nebula, and the lighter elements were thrown toward the outer part of the nebula, right? Density differences started. Why density differences started? I said because the nebula was undergoing condensation. Condensation led to contraction. Contraction led to decrease in the size of the nebula. With decrease in the size of the nebula, density of the nebula increased. I said density of the nebula increased, but the elements were not are not present in uniform density. So now now those elements are getting separated from each other. Understand that process of differentiation where the lighter elements are separating from the denser one. Denser material proceeding toward the center, and lighter elements are being thrown toward the outer part of the Earth interior. Earth is still in the gaseous state. Okay. This process continued for millions and millions of years, and what happened? What happened with more and more increasing density? Density inside the Earth, the temperature inside the Earth increased. With increasing temperature inside the Earth, what happened? The hot condition prevailing inside the Earth melted the most common element, the most common mineral of Earth, and that is your iron. Iron started melting, and when the iron started melting, iron came in contact with other minerals, that means your other elements, silica, magnesium, calcium, nickel. These all elements too were melted when molten iron came in contact with those elements. And that led to the development of a mixture of molten material. Now that mixture of molten material underwent what? Underwent chemical differentiation. Now chemical differentiation is taking place, because I said to you very clearly that chemical differentiation takes place in liquid state. Liquid state. And this is how now you have the beginning of that process for the origin and evolution of Earth interior, as well as origin and evolution of the Earth crust. So the third stage is the molten state of the Earth interior.
डिफरेंशिएशन का थोड़ा रिपीट कीजिए ना, वो क्या कंडेंसेशन के बाद कंट्रैक्शन, उसके बाद
I said condensation leads to contraction. Contraction will lead to compression of the nebula. छोटा होता जाएगा. When the nebula goes when the nebula experiences decrease in the size, what will happen to the interior part of the nebula? The nebula will experience increase in density. Increase in density will lead to increase in temperature inside the nebula. When temperature increases, now the dominant element inside the Earth is iron. So iron starts melting. We know that iron is the most dominant element inside the Earth. That is almost 35%. Then you have oxygen. Then you have silica. Then you have magnesium. These are the dominant elements. So when the iron started melting, that iron came in contact with other elements, like you have silica, like you have oxygen, like you have magnesium. These elements too came in contact with molten iron. Now you have development of a molten material, which is mixture of different elements. That means heavier and lighter elements. Which is the lighter element? Silica, oxygen, and then the heavier one is nickel and iron. So now you have the heavier elements getting separated from the lighter one. Like minerals form like group. This is the process we call it as chemical differentiation. Like mineral forming like groups. Like you have let me give you one example here. We have ferrous silica oxide. Yes, ferrous silica oxide. So this particular chemical compound is made up of what? Iron, silica, and oxygen. Okay. If this particular compound is in solid state and is subjected to high temperature and it starts melting, अगर melting हो जाए, so what will happen then? Now iron will separate from silica, and oxygen. Yes. This process of separation of lighter material from denser material is called as magnetic differentiation or chemical differentiation. So density differentiation is the process that is taking place in the gaseous state, and when the Earth is becoming hotter from inside, the iron starts melting. Iron melts other minerals also, and that leads to the development of a mixture of magma, which is having both denser and lighter material. Now that magma will undergo what? Churning, Churning. Okay. And that magma undergoes churning, where the lighter material will be thrown outside and the denser material will be proceeding toward the center of the Earth interior. This is your process, we call it as magnetic differentiation. So let us go to the third stage. Now, before, it looks complex. Let me start from here. Okay, start from here. So you have the magma. I said magma getting separated into two groups, one lighter and the denser magma. Right? How that lighter and denser magma, that means the lighter material and denser material will separate from the same magma. That is explained by one series, we call it as a series of crystallization of minerals, right? That is called as Bowen's reaction series, right? It says that those minerals, which are relatively heavier, those minerals tend to crystallize at very high temperature condition, right? Whereas the lighter mineral, they crystallize at a relatively lower temperature. Okay, just make one point here. This is your olivine rock, right? The first rock type, which is undergoing crystallization in the deeper part of the earth interior. This is your core, this is your mantle. I have not come to the crust here, right? Core and mantle. And what is happening now? Now you have the magma undergoing crystallization. Okay, that magma is having both type of mineral, the denser as well as the lighter one, right? The densest of the minerals will crystallize first, right? Which is the densest of the mineral? I said olivine, right? Olivines are made up of what? You can see here: iron, magnesium, and little amount of silica, right? Pyroxene rocks, they are made up of what? Iron, magnesium, and little amount of silica. So what will happen here? Iron, iron, nickel, magnesium, these are the denser mineral, and they are going to crystallize first, right? They are going to crystallize first, and then the rest part of the magma will further rise up. ठीक है? देखो ऐसा समझना है crystallization का मतलब क्या हुआ? If this is your magma, right? Magma is what? You know, the superheated molten material, the superheated state of molten rock is called as magma. Okay? Let us assume that this is a uniform magma. ये पूरा का पूरा uniform magma, right? And that magma is what? The magma is in liquid state. Yes. Now this magma is having different mineral composition, right? Denser, lighter, right? And then what are the denser minerals? You know, the denser mineral are iron, magnesium. So no, you have iron, magnesium, nickel. So the denser part of that mineral, right? Denser part of that, denser mineral which are part of this magma. Now, now they are going to crystallize first, because they can solidify, they can crystallize at very high temperature conditions. So they started what? They started settling first, right? So iron crystals were formed. Iron crystals, right? Crystals, याद रखना है, rock का development नहीं हो रहा है, ठीक है? You have crystals being formed, okay? The denser one settled here, that is iron, okay? Then you have crystallization further taking place, and which of the minerals will crystallize now? The minerals like nickel. Then you have crystallization taking place again, and you have now magnesium, magnesium crystallizing, and finally you have crystallization of the lightest material. Which is the lightest material? Which is the lightest element? The lightest element is silica. So you are starting your journey from here, from the deeper part of the earth, and you are moving toward the surface. Yes, this is how the rocks start. The rocks start being formed. That is the rocks are formed. So first of all, the denser crystals will start. The denser crystal will start form, and then after them will have relatively lesser denser crystals would be formed. That is your magnesium, and then the lightest of the crystals would be formed where? At the top part of the or you can say in the outer part of the earth interior. This is what is explained by one experimentation that is called as Owen's reaction series, and it is clearly said that those rocks which are having high proportion of iron, those rocks which are having high proportion of iron, magnesium, those rocks tend to crystallize at very high temperature. You see here 1200 to 1300 degrees Celsius, right? Whereas granitic rocks which are made up of what? Granitic rocks are dominated by silica. 75% of granitic rocks are made up of silicate material. Next is little bit of magnesium. Yes or no? Little bit of magnesium. Okay. So the most dominant one is silica, and silica being the lighter one, it starts crystallizing at a lower temperature. So as you are moving toward the Earth's surface, what will happen to the temperature? The temperature decreases, right? The temperature decreases, and this is how the churning process starts, where the denser one are settling first, and the lighter one are being forced toward the outer part of the Earth interior, right? This is the process we call it as. We call it as magnetic differentiation, or we call it as chemical differentiation, right? So this process went on for millions and millions of years. You have crystallized, those rock crystals being formed here. Again the magma is rising up. The magma is rising up. Now what is happening? You have magnesium settling down, and finally you have what? Finally you have silica settling here. Okay. This is how the separation of lighter and denser minerals have taken place. But this is not a one-time event, my friend, right? This is a repeated process, right? Repeated process. Now you see this one. See this diagram. Now the magma is rising up. Yes, the magma is rising up, and magma reaches toward the outer part of the earth interior. Now the magma starts cooling and solidifying. Rocks are being formed here. The answer is a rock has been formed here. It has cooled and solidified. Yes. Now, just because the Earth is a spherical body, so the total part of the magma is not coming out on the surface. The energy flow is in the form of convection current. Right? Convection currents. I'll talk about all those things in detail later on. So just I want to take a reference here. Convection currents are nothing but the pattern of energy flow inside the earth, where we have
where we have high concentration of ultramafic material or radioactive material in the upper part of the mantle, and that leads to the movement of the magma in two ways. One, right, upward rising, and the other one is downward subsiding. Okay. So this is your convection current which are generated, and now what is happening? The rocks are being formed here. Now, with the movement of the magma, this crust is primitive crust, and that is very thin. What is happening? Now the crust is being melted, right? And the crust is being teared apart, right? The crust is being teared apart, and this crust starts moving away from each other. Now this part of the rock has been divided into two parts, and this rock is being pulled towards the earth interior. क्या हो रहा है? The rock is again going back inside the earth, and it is being recycled. That means it is undergoing partial melting, right? Partial melting, and again what will happen to the rock? The rock will undergo melting, and the rock will be subjected to chemical differentiation. Again the lighter material will separate from the denser one, right? So this process of settling and resettling will continue forever, and that will lead to what? Deformation, recycling, rechurning of material taking place inside the earth, and slowly, gradually, we had the lighter material coming toward the surface of the earth interior, and the primitive crust came into existence, right? Primitive crust was formed. But the primitive crust was not The primitive crust was not stable. Why? Because it was continuously undergoing It was continuously undergoing deformation. It was continuously undergoing undergoing what? It was continuously undergoing churning, right? There are two reasons for this. One, I said convection current, and second is what? The meteoritic bombardment. Now meteorites are hitting the surface of the earth from all sides. Yes? Okay? When they hit the surface of the earth from all sides, you have primitive crust develop. Now the primitive crust is ruptured into many parts, right? It is broken into many parts. Okay, why? Because it is very thin. Okay? And why the meteorites are able to reach up to the surface of earth? Why the meteorites are not hitting today? Just because there was no atmosphere, right? There was no atmosphere. बात समझ में आ रहा है? The atmosphere has not come into existence. It has not developed into a stable atmosphere, right? And this process is continuing, right? Along with this, what is happening? Some more activity is taking place, and what is that? When the magma started cooling, right? When the magma proceeded toward the surface and started cooling, what happened? The gases which were dissolved in the magma, those gases were released, right? देखो, degassing is what? Degassing is a process when the magma converts from liquid state to the solid state. The dissolved gases in the magma starts escaping the solid material. Right now they cannot stay in the solid block. They are going to escape away. Right. So when that magma started cooling, the gases which were trapped or dissolved in the magma, those gases were released, and that led to what? That led to degassing. क्या बोलते हैं? Degassing. And slowly, gradually, we had what? We had a gaseous envelope, right? We had a gaseous envelope surrounding the earth developing, and that slowly, gradually, it evolved into a stable atmosphere. We'll talk about that later on. First of all, we have to keep in mind two things here, right? Magnetic differentiation is taking place in the third stage, right? In the third stage, you have magnetic differentiation taking place, and along with that magnetic differentiation, right, we have to keep in mind that the primitive crust which is coming into existence is subjected to meteoritic bombardment, and this primitive crust is now being recycled back, right? It is undergoing churning. Why? Because it is broken into different parts, right? And those parts are pulled towards each other. देखो अब क्या होगा? When these two parts are moving towards each other, what will happen? The primitive crust, that means this convection current is going to pull this part. It is going to pull this part under the other part, and ultimately it will undergo melting, right? Again that magma will undergo melting, and it will again rise up, right? Following the upward limb of the convection current, right? So this process of churning, recycling of material started taking place, and that ran for millions and millions of years, and that led to separation of denser material from the lighter one. Okay. So one point we have to keep in mind here is what the primitive crust has been formed. Okay, the primitive crust has been formed, but the primitive crust is not stable. Why? Because it is subjected to meteoritic bombardment. It is undergoing rupturing, right? And the ruptured part of primitive crust is now being recycled back, right? It is being recycled back. How that is being recycled back under the process of convection. We call it as convectional process. That means a cyclic process of energy transfer between two bodies, right? Between two bodies. So this is your convection current which are operating inside the earth, and ultimately, the primitive crust undergoes recycling. Okay, deformation, recycling, and again rechurning. That means again that magma which is formed inside the earth is being separated into two parts. The denser one settling in the lower part, and the lighter material is being thrown outside. Okay, this is your continuous process going on, and ultimately we had what? We had development of what? We had development of basaltic crust. क्या बन गया? We had development of basaltic crust. Basaltic crust is being formed here. This is your basaltic crust. And when I say basaltic crust, that means the oceanic crust are being formed now. ठीक है? बारिश शुरू नहीं हुआ, याद रखना है. बारिश तब तक हम लोग इन्वॉल्व नहीं करेंगे जब तक कि basaltic crust का फॉर्मेशन ना हो जाए. ठीक है? जब तक कि ओशनिक क्रस्ट का फॉर्मेशन ना हो जाए, हम लोग क्या करेंगे? will not take into account the event of what? Event of heavy rainfall, right? Because I told you very clearly that for the formation of granitic rock, there has to be large amount of water present in the area where the magma is flowing out, right? If that magma comes in contact with large amount of water, that will lead to exfoliation, and again the lighter material will separate from the denser one, right? Lighter material will separate. Like you see the basalt. Basalt का क्या composition है? You will find high proportion of magnesium. You will find iron and some proportion of silica. ठीक है ना? अब एक basaltic crust है, उसका क्या होने वाला है? That basaltic material is now undergoing chemical differentiation. So chemical differentiation is not stopping it does not cease to operate inside the earth. It is continuing process right from the deeper part to the surface of the earth, right? And slowly, gradually, what you are seeing, you have molybdenum rock, iron settling here, right? Then you go to the basaltic crust, you will find magnesium settling here, and finally you have silica coming to the outer part of the earth interior, right? Right. Once that is done, we can say that you have formation of continental part or the land area. Okay. Now, just to have a better picture of this, I'm drawing one more diagram here. इसको तो ध्यान रखना है, ठीक है? Basaltic crust का formation हो रहा है, ठीक है? Because maybe you'll have a confusion in this. So let me remove this confusion. So I said what? That you have this primitive crust. The thin crust was subjected to what? The thin crust was subjected to meteoritic bombardment. Okay? And that led to what? That led to rupture, that led to breakage in the crust, because the crust was brittle, the crust was thin, and it broke into different parts. Yes? चारों तरफ से meteorites hit कर रहे हैं, और आपको मैंने बोला क्यों meteorite hit कर रहे हैं, ठीक है? Right? And from inside that means from mantle, the magma is rising. Yes or no? The magma is rising, and that magma flow inside the earth is in the form of convection current. That is the established fact we all know now. We'll talk about that in detail when we deal with convection current, right? Sea floor spreading, all those things. So the pattern of energy flow which we have inside the earth is cyclic in nature. Pattern कैसा है? Cyclic. Okay. This cyclic flow of energy inside the earth is called as convection current, right? Those convection current are nothing but the movement of movement of hot plume, or you can say hot magma, and then cold magma, right? So see here what happens when you have this energy flow inside the earth taking place. And why that energy flow is taking place, my friend? When this density differentiation took place, what happened? The ultramafic material, you all know, or in simple terms you can say radioactive material. Radioactive, active materials, right? Radioactive materials, you all know, they are non-volatile. Yes, radioactive materials, they are They also underwent segregation, that means separation, right? Magnetic differentiation is taking place, and that led to concentration of radioactive material, right? Concentration of radioactive material in the upper part of the mantle. Okay? You know that you have asthenosphere, right? Asthenosphere has what? Asthenosphere has asthenosphere has very high temperature condition, and the material in asthenosphere is found in semi-molten state, right? Now why this is so? सब पे चल रहा है. I'm just giving a clarification here, क्योंकि जो आज हमको पता है उसी के बेसिस पे हम बोल सकते हैं ना कि क्या हुआ होगा. ठीक है, तो मैं अब जैसे मैं कन्वेक्शन करंट बोल रहा हूँ तो शायद बहुत लोगों को समझ नहीं आ रहा होगा. ठीक है, तो उसको एक्सप्लेन कर रहा हूँ कि कन्वेक्शन करंट है क्या. तो ये सारा प्रोसेस मैग्नेटिक डिफरेंशिएशन तो प्रोसेस चल ही रहा है. मैंने यहाँ पे आपको दिखाया, लेकिन आई एम नॉट गिविंग यू द साइक्लिक व्यू हियर, राइट? In this diagram, I am giving you a cyclic view. How that recycling will take place. Okay. So I said you have ultramafic material or radioactive material getting concentrated in the upper part of the mantle, right? 98% of radioactive material lies in the upper part of the mantle, right? And that leads to what? That leads to spontaneous release, right? Spontaneous release of heat, right? That means the radioactive decay leads to high concentration of heat in upper part of the mantle, and ultimately just think of that, that time when you have no crust developed, right? There is no crust developed. Now that material which is producing heat here, the heat is being transferred toward the outer layer of the earth interior, right? That heat transfer is in the form of what? Is in the form of convection current, right? Convection current. There are two parts of the convection current. One is the rising limb of the convection current, and the other is the subsiding limb of the convection current, which we now call as, क्या बोलते हैं अभी? We call them as hot plume. इसको बोलते हैं hot plume, and this is your cold plume. That means hot magma and cold magma. Now see here what happens when the magma is rising up. Yes, when the hot magma is rising up, it is approaching the surface, right? Temperature is decreasing, and it is undergoing crystallization, right? The magma cools and solidifies, and it develops into what? It develops into rocks. Rocks बन गए, solidify हो गया, ठीक है, right? Then the magma, just because the earth is spherical body, so the magma flow will continue, the energy flow will continue, right? This energy flow is continuing in opposite direction, and ultimately that is tearing apart the rock into two parts, and the rock is, that means this part of the rock will now be taken towards other destination, right? Here the magma is descending down. Why? Because as the magma is proceeding towards the surface, now the magma has undergone physical and chemical changes. क्या change होगा? यहाँ पे hot था, ऊपर आते हैं क्या हो जाएगा? It will become relatively more denser, right? It will be relatively, right? I said the magma will have relatively low temperature condition. I'm not saying that it will be cold, right? It will be having temperature which is relatively lower than the temperature of the hot magma. And now the magma is laterally spreading out, right? Laterally spreading out. And this thick, dense magma obviously would be pulled toward the earth interior. Anything which is denser, anything which is thicker, anything which is heavier is going to be attracted to the center of the earth, right? Now this magma is pulling this crust, and this crust is going down, right? Here you have what? Here you have the cold plume, right? Now this rock has been taken inside the earth. अब जब rock अंदर चला जाएगा तो क्या होने वाला है? Again magma would be formed, right? Again that magma will proceed toward the surface, and this recycling will go on and on, right? चलता रहेगा. जैसे कि एक बार में कभी बेसाल्टिक क्रस्ट का फॉर्मेशन नहीं हुआ है, ठीक है? कभी भी एक बार में कोई continental crust का formation नहीं हुआ है, right? It was a repeated process of melting, partial melting, and ultimately recycling of the material inside the earth, right? This is not the this is not the discussion we follow normally for explaining the origin and evolution of the earth crust. Why? Because it is a modern phenomena, we know that, right? But initially, when there was no crust, the magma was flowing freely, right? And because of the free flow of the magma, what happened? The magma, once the magma cooled and solidified here, the gases dissolved in the magma were quickly released. Right, degassing took place because there were many fractures on the surface of the earth. That means on the primitive crust. Okay, degassing went on, right? So the degassing चल रहा है और इधर क्या हो रहा है? Slowly you have lighter material separating from the denser one. जो relatively less dense है वो क्या होगा? ऊपर जा रहा है और जो ज्यादा dense है वो फिर नीचे जा रहा है. ठीक है? ऐसा recycling चलते जा रहा है. ठीक है? Right? अब ये रिसाइकलिंग होते होते क्या बन रहा है? You have basaltic crust being formed. Basalt का crust बन गया मतलब you have the origin of the oceanic crust. ठीक है? Oceanic crust has been formed, right? You know that oceanic crust are still right. You know, oceanic crust are still undergoing evolution, right? Oceanic crust are destroyed along the convergent boundary and they are created along the divergent boundary. ठीक है? जहाँ divergent होता है ये वाला divergent और जहाँ तक convergent होगा वहाँ क्या होगा? The crust is being destroyed. Okay? तो ये process चल रहा है. ठीक है? Still it is going on. So you have basaltic crust being formed, that means the oceanic crust, and now we are ready to see the next development, that is your origin and origin of the continental crust, right? अब next हम लोग क्या देखना है? Origin of the continental crust. Okay, and for that we have to shift our focus from internal process to the external process, right? What is that external event? The external event was degassing, right? Degassing led to what? Degassing led to formation of the secondary atmosphere. Slowly, gradually, we had just imagine, close your eyes and think of the earth having numerous cycles of volcanic eruption, right? The gases are being discharged, right? And the gases are surrounding the earth from all sides, okay? And it was not a transparent sky which you see today. जो आज दिखाई देता है ना कि हम आसमान को देख पाते हैं, वैसा नहीं था. पूरा चारों तरफ धुआं ही धुआं, ठीक है? You have water vapor and steam, right? So this process of degassing took place, and that led to what? That led to origin of the secondary atmosphere, right? A gaseous envelope started developing around the earth from all sides, and that was the beginning of the formation of the secondary atmosphere, right? But this atmosphere was having a problem. What was the problem? The secondary atmosphere which came into existence was still not stable. Why? Because the gases which were discharged during the degassing process were mainly dominated by water vapor. We had water vapor 60 to 70%, carbon dioxide 8 to 10%. Nitrogen gas, we had 12 to 15%, and there was no free oxygen. Okay? I mean, we can avoid discussion on this. Okay, ये हम लोग बाद में देखेंगे photosynthesis and all the process of diffusion. Yes or no? इसको छोड़ देते because we have to repeat this topic in climatology. Okay, origin and evolution of the atmosphere. Okay. And when I say atmosphere, keep in mind, now the earth has one atmosphere which is not the original one, right? This is the secondary atmosphere, okay? And the secondary atmosphere had dominance of which of the gases? These were the gases dominantly found in the secondary atmosphere, right? Okay? Now you have water vapor, carbon dioxide, these two gases are what? These two gases are greenhouse gas. Greenhouse gas. You all know greenhouse gas? Yes. That means the gases which are having property to trap the heat, right? They absorb the heat and they do not allow the heat to escape from, Escape from what? Escape from the lower part of the atmosphere. Okay? Right? Higher proportion of these gases will keep the earth's surface warmer. Yes or no? That is what we call as global warming. Yes or no? Now you have more and more carbon emission, more and more carbon dioxide, more and more carbon monoxide in the lower part of the atmosphere because of anthropogenic activity, and that absorbs the heat which is released by the Earth's surface. The heat which is released by the Earth's surface is what we all know. We call it as terrestrial radiation. ठीक है, right? Terrestrial radiation. तो ये degassing चल रहा वो है क्या? Degassing is nothing but the pressure releasing mechanism, right? Degassing is releasing, right? I mean, through degassing, the Earth is releasing its heat, right? But the heat is not, I said the heat is not quickly transferred to the space. Why? Because the greenhouse gases present in the secondary atmosphere are trapping the heat which is released from the surface of the Earth, right? And ultimately, the Earth was cooling, but the Earth was not cooling at a faster pace, right? Faster pace में नहीं हो रहा है. अब क्या होगा? अब यहाँ देखना है water vapor, बहुत सारा water vapor है, right? And when degassing is taking place, hot air is rising up, ठीक है? When the hot air is rising up, it will have high proportion of water vapor. Now, a part of that water vapor would be taken up into the altitude, that is in the upper part of the atmosphere, right? The air will undergo expansion. Expansion will lead to cooling. When the air cools, so what will happen to the moisture within the air? देखो दोनों अलग अलग चीज है, एयर अलग है, मॉइस्चर अलग है, ठीक है? एयर जो है मॉइस्चर को साथ में लेके चल रहा है, ठीक है? राइट? So air is taking that moisture along with it, and as the air cools down, what happens to the moisture? What happens to the water vapor that is present in the air? The water vapor too undergoes cooling, right? And ultimately, when you have super chilled condition, the water vapor converts into what? Water vapor converts into liquid state. That process is called as क्या बोलते हैं? Condensation, right? So when the water vapor was taken up into the altitude, right, that led to the cooling of the air. Cooling of the air led to cooling of the water vapor, and ultimately water vapor started converting into water droplets. ठीक है? बहुत सारे water droplets बनने लगे. ठीक है? But these are not rain drops. Okay? We'll talk about the process later on again in climatology, collision, coalescence process, ice crystal theory, ये सारा बात करना है. यहाँ पे हम लोग बस एक ही बात का ध्यान देंगे कि हम लोग को पता करना है कि हुआ क्या है, ठीक है ना? So when these processes operated, that led to condensation led to cloud formation, right? मतलब directly मैं cloud formation पे चला जा रहा हूँ, ठीक है? तो condensation led to cloud formation, and it is believed that the Earth was surrounded by a thick deck of cloud, thick deck of cloud from all sides, and Earth experienced heavy rainfall, continuous rainfall for 40,000 years. क्या हुआ? लगभग 40,000 साल तक लगातार बारिश हो रहा है, ठीक है? Right? Now, when first raindrop fell on the surface of Earth, what happened to the raindrop? Obviously, it was evaporated quickly because the Earth's surface is still very hot. Yes or no? Earth's surface अभी भी hot है. So that led to what? That led to evaporation. Now evaporation will lead to what? Again the water vapor would be taken up into the altitude, right? And that will lead to what? Condensation. Condensation will lead to cloud formation. Cloud formation will lead to precipitation, right? This process of evaporation, condensation, precipitation, evaporation, condensation, precipitation went on for millions and millions of years, right? Millions and millions of years, and slowly, gradually, what happened? Slowly, gradually, the Earth started cooling, right? The Earth started cooling because of two reasons. Number one, because of the heavy rainfall, right? And second, with heavy rainfall, what happened? Water vapor and carbon dioxide were dissolved. ठीक है? मालूम है कि जो पानी होता है, it is relatively denser than water vapor, right? So if you have heavy rainfall, what will happen to the water vapor? High amount of water vapor present in the atmosphere. Obviously, that would be dissolved, right? With the dissolution of water vapor, what happened? You have removal of one of the dominant greenhouse gas, right? If one greenhouse gas is removed from the atmosphere, what will happen? Now the Earth can cool very fastly. बात समझ में आ रहा है? Earth can cool very fastly. It can release its heat very fastly. Okay. Second was the dissolution of carbon dioxide. Carbon dioxide was dissolved, right? And that led to formation of, that means those solutions falling on the surface of Earth led to the formation of first carbonate rocks. First carbonate rocks were formed. You must have heard about limestone rocks. We know that limestone rocks right, limestone rocks are also, right, are also biologically produced. मालूम होगा ना, organically produced, ठीक है? अरे तो मालूम है ना, when the calcareous organism die, right, then they leave their skeletal part, and when they accumulate over each other, they give rise to one rock type that is your limestone. जैसे आपने coral polyps के बारे में सुना होगा, right, shellfish के बारे में सुना होगा, right? So when they die, what they leave their skeletal body which is right, which is calcareous in nature, right? ठीक है, because these all organisms are lime secreting organisms. So when they die, they leave their skeletal body which is dominated by, right, dominated by calcium. Even our body is having high proportion of calcium. Yes or no? The bones are made up of what? अरे हम लोग का bones किससे बना हुआ है? कैल्शियम एक important part है, और सबसे ज्यादा कैल्शियम कहाँ मिलता है? I mean, where you find largest amount of calcium over the surface of earth, in the soil, right? ठीक है? इसलिए बचपन में हम लोग मिट्टी खाते हैं, ठीक है? ये नेचुरल इवोल्यूशन है, ठीक है? आप लोग नहीं खाए होंगे, पता है मुझे, ठीक है ना? लेकिन हम लोग मिट्टी खाते थे, ठीक है? और चॉपस्टिक, स्कूल में चॉपस्टिक है ना, बहुत टेस्टी लगता था। अरे चॉपस्टिक, अभी तो मार्कर का इस्तेमाल होता है, पहले तो चॉपस्टिक होता ना, ब्लैक बोर्ड एंड चॉपस्टिक्स, राइट? ये नेचुरल हमारा बॉडी, जैसे भूख लगता है तो हम नेचुरली अट्रैक्ट होते हैं ना किसी चीज को खाने के लिए, ठीक उसी तरह से, ठीक है? तो this is your, right, this is your carbonate rock. The first carbonate rocks were, right, oldest carbonate rocks on the surface of earth. They have been formed, right, they have been formed during the time of evolution of, right, evolution of the earth atmosphere. Okay, so heavy rainfall taking place now, right, now you have heavy rainfall taking place, ठीक है? बारिश हो रहा है, and then you have, right, then you have the magma also rising up. भूलना नहीं है, अंदर जो चल रहा है चल ही रहा है, ठीक है? Right, the magma is rising up. Basaltic crust has evolved. The basaltic crust again is undergoing recycling, right? And when the magma comes in contact with water, I said, when the magma comes in contact with water, what is happening now? Now, right, that basaltic material, I said, that basaltic magma, which is having high proportion of magnesium, right, iron, and right, and some amount of silica, now that is undergoing what? Again undergoing chemical differentiation, right? Lighter material separated from, right, lighter material separated from the, right, from the denser one, and that led to what? That led to the formation of, continental nuclei. So this is your, right, this is your basaltic crust, and when a part of, right, part of the crust which came above the sea level, that became what? That became continental nuclei. Small pieces of land, right? Small pieces of land. A part of that, right? A part of that magma which, right, which came above the, right, above the sea level after cooling and solidification. Why? Because that magma, right, that magma has high proportion of silica, and as I said, when that magma comes in contact with water, what will happen? It will cool and solidify. Okay, and the lighter material of that magma which comes above the water, right? Not all magma, right? The lighter part of that material which comes above the water, after cooling, that becomes what? That becomes the continental nuclei. Small pieces of continental nuclei. That means this earth, right? This earth was, right, was what? This earth was surrounded by, it was occupied by small pieces of land. Small pieces of land on all sides. Okay? Okay? Continental nuclei बन गए, right? It was almost absent, I said. Almost absent initially, right? You had only like oceanic crust, and when the rainfall took place, that led to formation of, I told you very clearly, that led to formation of granitic rock or andesitic rocks, right? Andesitic rocks were formed. Granitic rocks are having what? Granitic rocks are having a chemical composition where you have dominance of silica, right? Okay? And sand, right? And those small pieces of land came into existence. Okay? This is the origin of continental crust. Origin का बात हो गया, ठीक है? बात समझ में आ रहा? How that origin took place? I said when that magma comes in contact with large amount of water, the magma undergoes exfoliation, right? जैसे मान लो आपने कभी क्या बोलो, मतलब कभी आग कोयला जलाया है, लकड़ी जलाया हो, ठीक है? और उसमें एकाएक पानी डाल के देखो, ठीक है? What happens, right? You'll find gas, dust, right, coming out, and then the residue is right, is relatively smaller than, right, than the residue which you saw, right, or the burning part of that material which you saw before applying water, ठीक है? पानी आप छोड़ दे तो क्या बचा? छोटा मोटा लकड़ी जो बच गया, ठीक है? है ना? तो जो लाइटर पार्ट है वो क्या हो रहा है, सेपरेट हो रहा है, राइट? द सिलिका इज सेपरेटेड फ्रॉम, राइट, सिलिका इज सेपरेटेड फ्रॉम मैग्नीशियम एंड नाउ यू हैव a new type of rock developing. That new type of rock is granitic rock, and that granitic rock is what? That granitic rock is lighter. Granitic rock is, right, is your continental nuclei, and this granitic, right, granitic material, this continental nuclei is now going to become the nucleus for the development of, right, for the evolution of the continental blocks, right? The larger land mass. You know that today the land mass occupies 29.2% of the surface area. Yes, ठीक है, पर उस समय कितना है? It is less than 2%. Okay, when the continental nuclei have come into existence, right? And that is your, right, that is your beginning of evolution of continental nuclei. ठीक है, अब उनका evolution शुरू होने वाला है. ठीक है, that means now the continental nuclei is under the process of sedimentation, accretion. What I said? Sedimentation, accretion. They will gain more and more mass. More and more mass would be added to, right, added to the margin of the continental nuclei, and they will slowly grow into larger, right, larger size continental blocks, right? The continental blocks of, right, of modern time. Okay, but before we come to this, I have to talk about, you know, yes.
सर ये क्या बोलते हैं इसमें वो वाटर वेपर जो कैसे बना है? ये अधिक कैसे में ये वाटर वेपर जो कैसे बना है?
That is purely based on the observation we have today. Like when we see volcanic eruption today, there are three kinds of material released during volcanic eruption. ठीक है? आपको कल मैंने एक चीज बताया था, प्रिंसिपल ऑफ यूनिफॉर्मिटेरिज्म, राइट? ठीक है, whatever observation we have today, we assume that the same processes are operated in geological time also, right? So when we see a volcanic eruption today, we find three kinds of material released from volcanic eruption. What are they? Solid, liquid and gases, right? Solid are your pyroclastic material, right? Those rock fragments. We'll talk about that later again during our discussion of volcanism. Second is your magma. Magma is of two types. One is sialic, the other is, right, one is sialic. We also call it as acidic magma, and the other is basic magma, right? अभी ज़्यादा इसमें नहीं बोलूँगा. तीसरा चीज क्या होता है? Gases, right? So when we see the volcanic eruption today, we find that the largest amount of gases which are released during volcanic eruption are water vapor and steam, right? Based on that, we have assumed that at that time also, right? At that time also, when this earth crust was formed, the volcanic eruption must have led to the release of what? Release of water vapor, carbon dioxide, methane, nitrogen. These are the gases. We have dominant gases released during volcanic eruption. Nobody has seen. We cannot imagine of those events what has happened in geological time, right? ठीक है, हम लोग का एज कितना है मालूम है ना? We are Homo sapiens. We are having an age of not more than 20,000 years, right? है ना? Or we are trying to reconstruct the history of the earth. Okay, so for that we have to rely on what? We have to rely on those events and the processes which are observed today, right? Based on those observations, we can safely assume that this must have been the case in geological time also. ठीक है, यही है ये. अब इस पे बहुत सारा explanation आएगा आगे चल के. When you study plate tectonics, you will come to know that when one plate is subducting onto the other, right, the plate along with the physical part, it is also taking large amount of water inside there, but that is only after the formation of oceans, right? तो confusing तो है ये बात, मैं खुद भी मानता हूँ, लेकिन हम लोग ने सीधा यही मान लिया कि वाटर वेपर रिलीज हुआ. ठीक है, जब न्यूमरस वोल्केनिक इरप्शंस हो रहे हैं, ठीक है, वाटर वेपर रिलीज आज भी होता है. ठीक है, but that is mainly because of what? That is mainly because of water seeping inside the earth along with the plate, right? And that leads to what? That leads to formation of magma, and that magma is mixed with water vapor and steam, and that provides explosive characteristics of the magma. The magma comes out in a violent manner. That is your characteristics we see in the Circum-Pacific Belt. ठीक है, तो यहाँ तो हमको यही बात मैंने बोला कि यहाँ पे हम लोग को पहले इसलिए मैंने क्लियर कर दिया कि फंडामेंटल कुछ हम लोग मेथोडोलॉजी फॉलो करने वाले हैं. ठीक है, right? We cannot have perfect understanding, but these are the relevant and I would say logical understanding we have created that this must have taken place, or this must have happened in geological time that has led to the evolution of any of the phenomena, be it your earth interior or any other things which we don't know, right? तो उसी के बेसिस पे बोलते हैं, इसका दूसरा कोई कारण नहीं है. अब हम लोग आते हैं कॉन्टिनेंटल न्यूक्लियस के बारे में थोड़ा सा बात कर लेते हैं एंड देन वी विल गो टू राइट. Then we'll go to the evolution part. These are four important behavior we have to keep in mind, right? Four important behavior as well as characteristics. You can call it as behavior or characteristics, right? ये चार बात हमको याद रखना है to understand the evolution of, right? Evolution of the asset. Evolution of what? Evolution of the continental crust. Oceanic crust का तो evolution हमको पता चल गया, ठीक है? Right? It said, right? It is said is right. It is known to us that you have, right? You have the oceanic crust which is basaltic in nature and that is still undergoing evolution. ठीक है? आज भी चल रहा है, लेकिन लैंड मास क्यों अलग है उससे? ये हम लोग को समझना पड़ेगा. तो continental nuclei are right. I said number one, they are lighter, they are cyanic in nature. Lighter and cyanic in nature. Second, they are buoyant, that means they always remain afloat. They always remain afloat. ठीक है ना? हमेशा वो तैरते रहेंगे. They will always, right? They will always remain afloat. They are buoyant, that means they are going to follow the law of flotation, right? Okay, law of flotation, and will never subduct. Will never subduct. Subduct का मतलब क्या हुआ? It will never be recycled back inside the earth, right? It cannot be pulled toward the earth interior. बस subduction को अभी फिलहाल इतना ही समझना है, ठीक है? Right? Subduction simply means when one plate undergoes the other plate, right? The denser plate undergoes the lighter one. That activity, right? That event is called as subduction, ठीक है? So it will never ever subduct, right? That is the reason why I said the land area is going to grow in coming time also, right? Okay, so land area is going to grow at the expanse of oceanic crust in the coming time also. Maybe we'll have maybe after billions of years from now, we'll have further expansion of the land area, which is now 29.2%. But maybe after billions of years maybe it can go to 35%, 40%. Anything can happen, right? Depending upon the intensity of movement, depending upon the direction of movement of the plates. Okay, so this is the second point we should keep in mind. Third, the continental nuclei, they will be in motion. They will be in motion. That means along with the oceanic crust, the continental crust too will be in motion. Continental crust भी motion में होगा और oceanic crust भी motion में होगा, ठीक है? तो ये हमेशा motion में रहेगा, लेकिन ये हमेशा afloat करता रहेगा, ऊपर ही रहने वाला है, ठीक है? It will never subduct. So the first difference we have to keep in mind between continental crust and oceanic crust is what? The oceanic crust is always subjected to deformation, recycling, whereas continental crust cannot be subjected to deformation, right? It cannot be subjected to recycling. The only way through which continental crust can be subjected to deformation is not by endogenetic force but by exogenetic forces, that is wear and tear, weathering and erosion, ठीक है? एक ही चीज हो सकता है और कुछ नहीं, ठीक है? Then if they are in motion, the continental nuclei will collide with each other and So these are right. These are 4 points we have to keep in mind. Right, that they are lighter, they are sialic in nature, they are buoyant, they cannot be right. They cannot be subducted, they cannot be recycled back inside the earth, and they are in motion. Right, motion. You know, motion is only because of what? That motion is only because of the convection current operating inside the earth, which are pulling the parts of the plate in different directions. Right, we'll talk about that in plate tectonics in detail. But again, taking reference from that point, we should keep in mind that you have the lithospheric plate in motion. ठीक है, lithospheric plate जो है वो motion में है, और lithospheric plate का 2 पार्ट है, एक continental plate और दूसरा oceanic plate, right? So right, both continental and oceanic plate are in motion, right? I said both are in motion, but in case of continental plate moving from one place to the other, the continental plate, if it interacts with any other plate, right, maybe any oceanic plate, then it is not going to subduct. The oceanic plate will subduct under the continental plate, right? So it is going to remain in motion, and ultimately the continental nuclei may collide with each other, right? There can be 2 possibilities: collision, that means convergent movement, and divergent movement. 2 ही तरह का movement possibility है, ठीक है? Divergent movement में continental mass का growth नहीं हो सकता, ठीक है? So only possibility is what? Collision. Collision will lead to what? Collision will lead to sedimentation along the margin or the platform of the continental nuclei. And sedimentation will ultimately lead to what? Sedimentation ultimately will lead to increase in the size of the continent. So let us understand that these continental nuclei are what? These continental nuclei are the most altered rocks of the world. दुनिया का सबसे पुराना और सबसे altered मतलब सबसे complex, right? The most complex rock of the world are represented by continental nuclei. They are the oldest one. याद रखना है. They are the oldest rock. Okay. The oldest dated rock found on the surface of Earth comes from where? Comes from the continent. याद रखना है. That is 4.1 billion years of age. Right? That is the oldest dated rock, and that has come from where? That has come from Canadian seal. Canadian seal. अब मैं एक छोटा सा आपको दिखाता हूँ यहाँ पे. ये देखना है जरा. Can you see this one? This is Laurentian plateau, right? And this is your dark brown, right? Brown color zone that is representing Canadian seal. ठीक है? That silt is what? Silt is the part of the craton or the oldest continental nuclei which evolved during the primitive phase of Earth evolution. And this craton has 2 parts. One is your silt and the other is क्या बोलते हैं इसको? The other is called as platform. So the margin of those continental nuclei are called as platform. These platforms are nothing but partially submerged part of land. ठीक है? ये पानी है और ये क्या है? Continental nuclei का part which is submerged under the water, right? Now what will happen to this submerged part? अब देखना है यहाँ पे. There can be 2 possibility again. 2 तरह से हो सकता है. क्या? If you have magma rising here and you have one more continental nuclei here having platform. This is the platform, okay? ये दोनों का platform है. This is your silt and this is your platform, ठीक है? And then you have the magma rising up, ठीक है? Magma rising up. When the magma rises up, the hot plume, wherever you have the rising lip of the convection current, those are the zone of divergent plate boundary. Divergent plate movement takes place, ठीक है? लेकिन divergent plate movement से पहले जो होता है वो क्या है? The magma comes out and equally gets divided into 2 parts, depositing itself on the margin of what? Margin of the continental nuclei, right? And then this moves away. ये वापस दूर चला गया, ठीक है? Again you have new round of magma, right? This material has come where? This material has gone there. यहाँ पे चला गया. ठीक है? After some time, and now you have another round of magma coming up, and that is getting deposited here, right? After some time, again the magma moves away, and then this is how, right? This is how, you know, more and more sedimentation is, right? More and more sedimentation is seen along the, right, along the margin of the continent, right? The best example is, you can see here. The best example is North and South America. Here is your, yeah, here is your mid-Atlantic ridge. Okay? आप एक काम करो, you all have study material with you. Yes. See that page number 88. यहाँ पे देखना है कैसे. You find a boundary, you find a map there. आप सभी को एक एटलस जरूर खरीदना है, ठीक है? और मैंने लिख के भी वहाँ पे दिया हुआ है लिस्ट में. तो एटलस जरूर ले लेना. और ये ब्लैकस्टोन एटलस बहुत है. So this is your divergent boundary. Can you see the divergent boundary? What is happening here? More and more mass of material is being added. और क्या होते जाता है? क्या होता है? ऐसा. Step-like features are developed like this. ठीक है? Step-like features are developed like this. Layer after layer, you have magma getting, right? Magma getting deposited. Magma deposit हुआ, फिर plate move कर गया. Magma deposit हुआ, plate move कर गया, right? And the newest of the, right, the newest of the crust is where? Here. यहाँ पे नया crust है. And this crust is what? Oldest. This is newest. This is your oceanic crust. Yes. बात समझ में आ रहा है? This is how, right? This is how the, right? I said this is how more and more mass can be added to the, right, to the margin of the sill. ठीक है? अब उसको बंद करना है, यहाँ देखना है. एक तरीका इससे हम देख सकते हैं कि क्या हुआ, डाइवर्जेंट प्लेट में क्या हो रहा है कि सेडिमेंटेशन हो सकता है, ठीक है, थोड़ा थोड़ा मार्जिन में हो सकता है, बट अगेन दैट पार्ट ऑफ लैंड और राइट और दैट मैग्मा इज नॉट कमिंग अप, राइट, कमिंग अप अबव द वाटर, राइट. सेकंड इज व्हाट, द सेकंड इज द सेडिमेंट व्हिच आर ब्रॉट फ्रॉम द लैंड बाय द रिवर्स. रिवर्स भी तो सेडिमेंट लेके आएंगे ना, बिकॉज़ वेदरिंग इरोजन इज गोइंग ऑन एवरीवेयर, राइट. अरे जहां भी अर्थ सरफेस है वेदरिंग इरोजन तो होगा ही ना, चाहे कुछ भी कर लो, चाहे वो हायर इंटेंसिटी से हो या लोअर इंटेंसिटी से, राइट. वेदर इट इज फास्टर और स्लोअर, यू विल हैव वियर एंड टियर ऑफ द रॉक्स, राइट. And that weathered material, right, that weathered material would be brought by the rivers. You know the rivers are the dominant agent, right? They will follow the slope and the sediment would be deposited where? Here, right? If this continues for, right, for millions and millions of years, what will happen? If the rate of sedimentation is higher than, I said, if the rate of sedimentation is higher than the level of water, ultimately what will happen? Ultimately that will lead to increase in the size of, right, size of the land. Now the land has, right, land has further, right, further expanded. ठीक है, ठीक है. तो sedimentation can be of two type. One is your deep sea sediment, जो मैंने यहाँ बताया आपको, ठीक है. Second is the sediment brought by the rivers, right. Now the third possibility, and that is the most important one. And what is that? When the continental nuclei are colliding with each other, ठीक है. जब collision हो रहा है तो क्या होगा? बेस्ट एग्जांपल है, आपको ज्यादा समझ में आ जाएगा बहुत क्लियर से कि क्या हो सकता है उस समय, कैसा हुआ होगा. तो यह कॉन्टिनेंटल न्यूक्लियाई, ऐसे कॉन्टिनेंटल न्यूक्लियाई having two part, sill and platform, ठीक है. This is your sill and this is your प्लेटफॉर्म. ये प्लेटफॉर्म है, ठीक है, दोनों का. अब क्या हो रहा है, प्लेट क्या कर रहे हैं, द कॉन्टिनेंटल न्यूक्लियर आर मूविंग टुवर्ड्स ईच अदर, कोलिजन होने वाला है, ठीक है. कन्वर्जेंट प्लेट मूवमेंट, ठीक है, कोलिजन. अब क्या होगा, now what will happen here, you know that, right, you know that these two cratons will move towards each other, and ultimately these two parts will come closer, right. This part, right, these two parts will come closer. One of the part which is relatively more denser, कोई भी हो सकता है, this one, anyone, right? Yes or no? I mean these two both are, right, both are what? Both are oceanic crust, right? I mean anything which is under the water can be called as oceanic crust, simple, right? Any part of the crust which is under the ocean can be called as oceanic crust, simple, right? So this is your, right, this is your oceanic crust, and now, right, now it is coming in contact with other oceanic crust. So what will happen? One of the plate which is relatively more denser will subduct under the other, right? Yes, subduction will take place, deformation will go on, the magma will rise up, again the magma will be deposited here, ठीक है, volcanic eruption, ठीक है. With further movement of these two continental blocks towards each other, what will happen? The oceanic plate could be crumbled. That would be subjected to deformation, right? Deformation will take place. That means fracturing, deformation. The rocks will be subjected deep inside the earth. Again, the rocks will undergo melting, and again the molten material will come out. Again, that molten material will solidify, and that will develop into a new material that can be igneous material, right? If these two sealed are moving towards each other, now the platform has been consumed, right? Ultimately, this new material will be subjected to what? This new material will be subjected to compression, right? And compression will lead to what? Compression will lead to bending and folding of the rock strata here, and then stitching would be done, right? Now, what was the surface area of this crater? This was the surface area, yes? The part which was above the land, yes? Now, what is the surface area? The surface area has increased from here to here, ठीक है? जैसे आपने, मैं सारा डिटेल यहाँ पे नहीं बोल सकता हूँ, फिर भी आपने ये कहानी तो सुना होगा ना, you have Eurasian plate and you have Eurasian plate and Indian plate separated by one geosyncline, a shallow depth of water zone, or one oceanic crust. This is your Indian plate and this is your Eurasian plate. Yes, Indian plate was moving toward the north. Yes, and what happened? The oceanic plate was, that in the Tethys Sea was subjected to deformation. ठीक है ना? Deformation हुआ, recycling हुआ, and new material started evolving, and ultimately after millions and millions of years, we had igneous material being deposited here. Those igneous material were subjected to what? Those igneous material were subjected to intense compression when Indian plate came closer to the Eurasian plate, and that led to what? That led to bending and folding of the strata and formation of two mountain range. You all know that is Inner and Middle Himalaya. And Tethys Sea was completely closed. ठीक है? आपने आगे चलकर हम लोग पढ़ेंगे अंगारा लैंड, गोंडवाना लैंड, ये मेडिटेरेनियन सी जो देख रहे हो ना, that is the remnant of your Tethys Sea, जो बचा कुचा पार्ट है, right? Here the Tethys Sea has been completely consumed, ठीक है? Right? So this stage of continental growth, I said, this stage of continental growth is explained in the form of microplate tectonics. So we had this phase of microplate tectonics for billions and billions of years, and that got completed. I said that got completed by 2.5 to 3 billion years. It was completed. माइक्रोप्लेट कंप्लीट हो गया, ठीक है? माइक्रोप्लेट देखो, अभी इसको फिर समझने की जरूरत है. Microplate tectonics, classical plate tectonics, right? These two phases of tectonics help us in understanding the evolution of the continental blocks, right? Expansion of the land area, right? Why the land areas are expanding? The land areas are expanding under the process of sedimentation, accretion, right? And that sedimentation accretion is mainly driven by collision, right? Because the continental nuclei are not recycled back inside the earth, they are always floating, right? And slowly, gradually, that leads to expansion in the size of the land area. ठीक है? धीरे-धीरे land area का expansion होते जा रहा है, ठीक है? That is called as microplate tectonics, right? This phase of tectonics is microplate tectonics. The tectonics which we study today, we call it as modern plate tectonics, right? Modern plate tectonics can only talk about those phenomena which are recorded along the modern plate boundary, right? Modern plate boundary. It cannot explain those phenomena. The phenomena of orogeny, the phenomena of volcanic activity, seismic activity, which are taking place intra-plate. That means which are taking place within the plate. Okay. So microplate tectonics led to what? It led to stitching activity, right? Stitching of the Earth's surface, and ultimately the land area, from smaller proportion, the land area reached up to almost 20%, right? During microplate tectonics, right? Okay. Though the highest increase in the land area was seen under modern plate tectonics. जब हम लोग modern plate tectonics का देखते हैं, ठीक है? क्योंकि ये बहुत समय तक चल रहा है ना, आप देखो 3 billion years तक, ठीक है? 4.6 billion years, that is the age of Earth, and by 3 billion years, what is happening? Microplate tectonics is over, ठीक है? तो ये आपको समझना पड़ेगा कि हम लोग माइक्रो प्लेट टेक्टोनिक्स क्यों बोलते हैं, क्योंकि उस समय कॉन्टिनेंट कैसा था, छोटा छोटा, ठीक है, न्यूक्लियाइज, सुनो, right, the plates were micro plates, not right, not the plates of modern time, okay, but now you have, right, now you have those plates of modern time, and they are, right, they are able to explain those phenomena which are recorded along the plate boundary only. Let me give you one example. You again see page number 88 और इसको देखना ध्यान से, see page number 88 and just tell me, right, tell me why we have Himalayas here. अगर मैं आपको पूछूं why we have Himalayas here, why we have Himalayas here? Now see page number, right, page number 88. Can you locate that boundary? What kind of boundary you see in India to the northern part of India? बिल्कुल लेफ्ट में देखना है, इंडिया दिखाई देगा आपको. Do you find convergent boundary? Yes. अरे हाँ या ना? That is the modern plate boundary. उसको देख के हम क्या बोल सकते हैं? We have Himalayas here because, right, because here along this zone you have, right, you have convergence or collision between two plates, that is Indian plate and Eurasian plate. And the material which was lying along the margin of these two plates was subjected to compression, and that led to, right, that led to evolution of the bended folded strata, that is your Himalaya. Very good. Now you tell me, right, can you explain why you have Aravallis here? Can you explain why we have Ajanta Satmala range here? Can you explain why you have Annamalai range here? Can you explain why you have Eastern Ghats here? You cannot explain. Why? Because there is no modern boundary. Can you see any modern boundary within the plate? No. Right? These all are fold mountain chains. Right? These all are fold mountain chains, which confirm to the fact that the Indian plate which you see today as one large unified plate, it was not the same in geological time. It was not the same in geological time. Right? It was having multiple fractures. Right? It was separated by those, right, those shallow depth of water, we call them as geosyncline, right? And sand, right, and those smaller part, that means those minor plates, those micro plates collided with each other, and that led towards stitching, right? And ultimately that gave rise to a mid-sized plate that is called as classical plate, right? You have Aravalli mountain here. Why? Because the geosyncline was here, and two part of the geosyncline collided with each other, and that led to what? That led to deformation of geosyncline. New material got deposited, that was subjected to compression, and it evolved into a fold mountain chain, right? So for understanding intra-plate dynamism, we cannot rely on modern plate tectonics. Are you getting my point? Modern plate tectonics only talks about modern phenomena, right? You have to go back in time, and you have to, right, फिर से वही यूनिफॉर्मिटरिज्म. अगर अभी टेक्टोनिक्स हो रहा है, इसका मतलब जियोलॉजिकल टाइम में भी टेक्टोनिक्स हो रहा होगा, ठीक है? जियोलॉजिकल टाइम में कौन सा फेज चला पहले? माइक्रो प्लेट टेक्टोनिक्स. व्हाई? बिकॉज़ द प्लेट्स वेर ऑफ स्मॉलर साइज, राइट? देयर वर लॉट ऑफ फ्रैक्चर, एंड अर्थ, राइट, अर्थ by following these two kinds of movement, that is your convergent or divergent movement. Especially in the case of convergent movement, what has happened? It has done stitching on the surface of earth, right? जैसे हमारा शर्ट है, हमारा पैंट है, हमारा स्टिचिंग है ना सब जगह, ठीक है? To give it a shape, है ना? और सबसे वीक पार्ट कहाँ है? जहाँ पे स्टिचिंग हो रखा है, ठीक है? If you will pull this part, where will have the maximum pressure? Stitching, ठीक है? Right? तो ये बेंडेड फोल्डेड स्ट्राटा कुछ भी नहीं है, ये माउंटेन कुछ भी नहीं है. दिस इज जस्ट ए स्टिचिंग एक्टिविटी ऑफ द अर्थ, राइट? Stitching has been done, and what happened? Those micro plates stitched together, they gave rise to what? They gave rise to a classical plate. थोड़ा बड़ा प्लेट बन गया. When classical plate collided with each other, that gave rise to what? That gave rise to modern plate. ठीक है? अभी आप देखो, you can see Pacific Ocean. देखो Pacific plate. Can you see that Pacific plate? Right? Even that Pacific plate is having many divisions, है ना? It is not a single largest plate. Single plate नहीं है, right? There are many fractures. लेकिन शुरुआत में कैसा रहा होगा? शुरुआत में इसका जो आज 2-3 जैसे देख रहे हो आप ना, नाचका प्लेट, कोकोस प्लेट, है ना? उस जमाने में आप क्या देखेंगे? मतलब जियोलॉजिकल टाइम में क्या होगा? इसका मतलब there would have been millions and millions of such, right, such fractures, right? Okay, are you getting my point? So this stitching activity has made micro plate to classical plate, and classical plate has evolved into modern plate. Okay.
उस समय का लेट फॉर्म भी अलग अलग होगा. लाइक ये माइक्रो जो लेट फॉर्म था ना, और अभी का जो मॉडर्न लेट फॉर्म है वो अलग था.
देखो अब ऐसा समझना है कि लैंडफॉर्म्स का बात कैसे करेंगे हम लोग। लैंडफॉर्म्स का बात तब करेंगे ना जब हम लोग एक बार प्रोसेसेस के ऊपर बात कर ले, मतलब जियोमॉर्फिक प्रोसेस, एंडोजेनेटिक प्रोसेस का बात कर ले। आई एम नॉट टॉकिंग अबाउट दैट ना। लैंडफॉर्म के बारे में बात करेंगे तो देन यू हैव टू राइट, देन यू हैव टू ट्रेस बैक टू देयर एज ना, व्हिच काइंड ऑफ लैंडफॉर्म यू आर टॉकिंग अबाउट।
आप जो आगे बोला था जो डीप सी सेडिमेंटेशन लेना, उसमें मतलब वो जो आधा रिवर से भी सेडिमेंट लाया बोला ना, तो वो मतलब रिवर जो कहाँ से फ्लो होगा?
रिवर क्लाइमेट होगा तो क्या होगा, बारिश होगा, बारिश होगा तो क्या होने वाला है, you'll have rain water falling on the surface of land, and then the rain water is going to follow the slope. अच्छा बारिश होता है तो पानी कैसे जाता है?
उस समय का स्लोप और आगे का जो स्लोप है ना, वो अलग
बिल्कुल अलग होगा, बिल्कुल अलग होगा। आपको ये समझना है कि स्लोप का बात अभी हम कैसे करेंगे, लैंडफॉर्म का बात कैसे करेंगे, कौन सा लैंडफॉर्म जानना है। यू वांट टू नो माउंटेन, यू वांट टू नो प्लेट्यू, यू वांट टू नो एनी विच टाइप ऑफ लैंडफॉर्म।
सर वो मतलब रिवर, आप जो रिवर फ्लो बोला था ना उसको
हाँ, तो इसलिए बोल रहा ना, रिवर के लिए हमको समझना पड़ेगा ना कि क्लाइमेट क्या है, ठीक है, कब बारिश हो रहा है, फिर कहाँ पे ग्लेशियर्स फॉर्म हो रहे हैं। तो रिवर्स तो अभी मैं मतलब कौन सा रिवर के बारे में बोल रहा हूँ, जैसे गोदावरी के बारे में बोलूंगा तो चलो नॉन पेरिनियल रिवर है, बट इफ आई टॉक अबाउट हिमालयन रिवर, दे आर ऑल आर पेरिनियल रिवर, राइट। They are drawing their water both from rain water as well as snow melt water, that is coming from the glaciers, when the glaciers are melting, ठीक है। तो उसका बारे में बाद में बात करेंगे। लैंडफॉर्म्स स्लोप एक जैसा कभी नहीं रहता, ठीक है। स्लोप कभी, स्लोप का क्या मतलब हुआ, स्लोप राइट, स्लोप इज द इंक्लिनेशन ऑफ द लैंड, राइट। सो इफ से राइट, if the landform right, or if the crust is evolving, we are dealing with the basic landform, which is the basic landform of the earth's surface. The basic landform is continental crust and oceanic crust, right. Once we complete this, then we can talk about the landform which we have over the continental crust and over the oceanic crust. Then you can bring in the exogenetic processes, and then when we talk about exogenetic process, we can talk about the rivers, right? How the rivers have originated, and that again depends upon different regions, right? Different regions have different modes of origin and evolution of the rivers. But the most important part is that the rivers are having their origination because of the climatic condition. Wherever you have heavy rainfall, those are the zones of perennial river. You'll find the largest of the river where? Do you find the largest and longest river in say in temperate belt or polar area? No. Where you find? In the tropical belt. Why? Because tropical belt is having the tropical belt is having warmer condition, and it also receives heaviest of the rainfall. Okay. This amount of rainfall we do not find in any other part of the world, right? तो धीरे धीरे इतना ज्यादा पजल नहीं होना है, धीरे धीरे थोड़ा एक एक स्टेप करके चलना है, नहीं तो बहुत कंफ्यूज होंगे, ठीक है। अभी रिवर का ओरिजिनेशन में बताऊंगा तो मुश्किल होने वाला है, ठीक है। तो इतना बात समझना है कि रिवर, मैंने रिवर का एग्जांपल क्यों लिया, बिकॉज रिवर इज द मोस्ट डोमिनेंट एजेंट ओवर द लैंड एरिया, which covers 60%, not 70, 60% of the land area, right? And this is the network of river stream which is doing what? Which is weathering the surface, right? Weathering and eroding the surface. So that eroded material is transported down the slope, and that would be dumped somewhere. Where? That would be dumped in the low-lying area. This is the low-lying area in the case of it crater, right? That means that sediment would be dumped in the platform areas, that means the margin of the sea. Okay. इसी तरह से हमारा लैंड का एक्सपांशन होगा, ठीक है। Okay, now come to the next part. I said microplate tectonics is over, and we had those continental nuclei slowly growing in size. You know the process, and some of the supercontinents were formed. अभी भी यहाँ पे भी supercontinent का formation हुआ है, right? Supercontinents were formed after the completion of microplate tectonics. We had four supercontinent. Just example दे रहा हूँ मैं आपको. Then you have Columbia supercontinent, Atlantic supercontinent, Arctic supercontinent, Ketoland supercontinent, ये सारे supercontinent बन गए, ठीक है। And then came the second stage, that was the classical plate tectonics. classical plate tectonics. And here what is happening? You have more and more island arcs are being formed. Volcanic eruption हो रहा है, and then that is leading to what? Convergent movement, and you know one of the plate will subduct, right? One of the plate will subduct, and that will lead to what? That will lead to the melting of the melting of the crust. That will lead to accumulation of magma. Magma will rise up, and then and those volcanic arcs will be developed. Those volcanic arcs will develop where along the margin of the along the margin of the continental blocks. आज भी देखेंगे आप, like you see this one, Japanese archipelago, ठीक है? Hokkaido, Honshu, जितने आइलैंड देख रहे हो कहाँ पे है? This is lying where? In the platform area of Eurasian plate, ठीक है? Right? So island, volcanic island arcs were formed and that added more and more, ठीक है? देखो कुछ भी सब्सटेंस अगर पानी से ऊपर आ जाए तो क्या बोलेंगे आप? लैंड एरिया का इंक्रीज हो गया. Or yes or no? If that magma comes above the water, you can safely say that it is land. Simple, right? And ultimately that led to what? That led to increase in the surface area of the land. धीरे-धीरे land का area बढ़ते जा रहा है, ठीक है? That is your classical plate tectonics, and that ended around 1 billion years ago. 1 billion years ago. And that also led to the formation of one supercontinent, that was Rodinia. Rodinia supercontinent का formation हो जाता है करीब 900 billion years पहले, ठीक है? अब देखना है ये Rodinia supercontinent बन गया है, ठीक है? All the supercontinent, whatever supercontinent I am saying, all the supercontinents have been formed and again they have broken down, ठीक है? Recycling, वही समझना है. तो सब कुछ का रिसाइकलिंग चल रहा है. ओशनिक क्रस्ट का हमेशा रिसाइकलिंग हो रहा है, बट कॉन्टिनेंटल क्रस्ट क्या है? हमेशा ऊपर है, राइट? So this is your These are the supercontinent which have been formed in the geological time, and in the classical plate tectonics. With the end of the classical plate tectonics, what happened? We had the formation of one supercontinent, that was Rodinia, right? This Rodinia again broke down. क्या हो गया? फिर से break कर गया. It broke down in 750 million years ago, right? लगभग ये फिर से break कर जाता है. And finally, this Rodinia, that means the broken part of Rodinia, it combines again. फिर से combine होता है, right? That is around 700 to 600 million years ago. Sorry. It broke down and again it combined together in around 300 million years ago. Again into one supercontinent, which Wegener called as Pangaea, ठीक है? Pangaea का formation हो गया, ठीक है? Right? And from the formation of Pangaea, this is the beginning of what? This is the beginning of modern plate tectonics, ठीक है? Modern plate tectonics. ये शुरुआत होता है Pangaea formation के बाद, ठीक है? आप समझना है प्लेट टेक्टोनिक्स क्या कहता है? प्लेट टेक्टोनिक्स confirms to the fact that there was not only one Pangaea, there were two Pangaea, right? The Rodinia supercontinent which you see here, right? Rodinia जो है यहाँ पे, Rodinia जो supercontinent है, असल में प्लेट टेक्टोनिक्स इसको ही क्या बोलते हैं? That was Pangaea 1, right? Though the time period is little bit different, that is 750 to 800 million years ago. This is what plate tectonics says, modern plate tectonics, जो theory है वो कहता है, ठीक है? And then, according to plate tectonics, you have this Pangaea 2 that developed in Carboniferous period, somewhere around 300 million years ago, ठीक है? बात समझ में आ रहा है? तो Pangaea formation के बाद हम क्या देखते हैं? After the formation of Pangaea 2, according to plate tectonics, we had the beginning of modern plate tectonics, right? That also means that under this phase of modern plate tectonics, we had the maximum increase in the land area. सबसे ज्यादा हुआ, ठीक है? अब briefly बताता हूँ क्योंकि ये सारा बात हम लोगों को continental drift में करना है. तो पूरा यहाँ पे स्टोरी नहीं सुना सकता हूँ, तो छोटा सा स्टोरी सुनाऊंगा. You know that when this Pangaea was formed, this Pangaea was formed where? The Pangaea was formed in the South Polar region, right? This Pangaea was surrounded by water body, largest water body, that was Panthalassa, right? Then Pangaea broke into two parts, Angara land, Gondwana land, right? Angara land consisted of what? Angara land consisted of North America, Eurasia, yes or no? Gondwana land consisted of South America, Africa, India, Australia, Antarctica. सारे इसके लैंड मास थे, ठीक है. एंड देन द Pangaea started moving toward the north. Yes, that means Angara land, Gondwana land both started moving toward the north, right? These land masses separated from each other. That means your right. That means your Africa, right? Africa separated from South America, India separated from Australia, and these all land masses started moving toward the north. Yes, right. In between these two was like what? You know, when Angara land and Gondwana land was formed, the intervening space of shallow depth of water that was occupied by an arm of Pacific Ocean was called as what? Tethys Sea, or right, or a geosyncline, you can say, right? This geosyncline was subjected to compression, fracturing by African plate, Indian plate, and that led to formation of what? That led to formation of Alps mountain, that led to formation of Himalayas, that led to formation of Kulnun mountain. Yes or no? ये सारा फॉर्मेशन होता है, ठीक है. अच्छा, माउंटेन फॉर्मेशन का क्या मतलब होता है? माउंटेन फॉर्मेशन simply means addition of more and more land, right? More and more area to the land, and ultimately maximum increase in land area was seen when during modern plate tectonics, ठीक है. You know, Alps were formed, Himalayas were formed, Andes were formed, Rockies were formed. So these all land masses have evolved from where? और ये सारे जो माउंटेन हैं कहाँ से बने? From where that material has come? The material has come from the oceanic crust, right? Yes or no? The material has come from the oceanic crust. So what is happening here? The oceanic crust is right. The oceanic crust is shrinking, right, and it is giving way to what? It is said is giving way to more and more continental mass, right? And that is how the land mass came to the extent of around 29.2%, right? ठीक है. ये मॉडर्न प्लेट टेक्टोनिक्स है. सबसे ज्यादा लैंड मास का गेन हुआ कब? Pangaea 2 के बाद, ठीक है. जो वेगनर का Pangaea 1 है, मतलब Pangaea उन्होंने 1 2 नहीं बोला है, आपको पता है, उन्होंने यही बोला कि Pangaea फॉर्मेशन हुआ, राइट. बट हम लोग प्लेट टेक्टोनिक्स को फॉलो कर रहे हैं. इफ यू फॉलो दैट यू नो that modern plate tectonics theory, then it says that Pangaea 1 was formed around 750 to 800 million years ago, and then Pangaea 2 was formed around 300 million years ago, and that coincides with the time period suggested by Wegener. Yes or no? So that is your Carboniferous period, ठीक है. और उसका फिर ब्रेक हो जाता है. और आपको मालूम है, I told you that very recently, last year only, a group of scientists, they have prepared a circulation model, and they say that third Pangaea is going to be formed, right? There will be formation of a new Pangaea, right? Third Pangaea, and that will be formed almost 500 million years from now, okay? But this time, the Pangaea or the supercontinent would not be formed where? It will not be formed near the South Polar region, but this time that will be formed near the equatorial belt, okay? And that is one disturbing news we have for our Earth, because you know that if the Pangaea is formed near the equatorial belt, that will lead to the melting of polar ice caps, right? अरे इक्वेटोरियल बेल्ट तो गर्म होता है ना, मालूम है ना. You have high temperature conditions. So what will happen? The polar ice caps will melt. If the polar ice cap will melt, what will happen to the sea level? Sea level will rise up, and there are many countries which are littoral countries, which are having their average height above the sea level in between 5 to 10 meters only, right? So what will happen to those countries like Fiji, Tuvalu, Mauritius, Maldives? क्या होगा? सारे flooded हो जाएंगे, सारे खत्म हो जाएंगे, ठीक है. So that is going to create a disaster, right? And second, that is also going to lead to a scarcity of fresh water, because you know that polar ice caps are also source of fresh water, ठीक है. तो ये दोनों प्रॉब्लम हो सकता है. और उससे फिर क्या होने वाला है? Obviously that will have an impact upon flora and fauna also. Flora and fauna, right? That means animal life and plant life, ठीक है. And ultimately having impact upon whom? We, right? We who are at the top of the ecosystem, you know? ठीक है. हालांकि इतना चिंता नहीं करना, हम लोग का जैसा बिहेवियर है, हम लोग इतना मतलब ये सब देखने के लिए बचेंगे नहीं, ठीक है. ज्यादा से ज्यादा 1000-2000 साल अभी से, ठीक है. मैक्सिमम 1-2000 years right from now, because we are going to finish each other, right? है ना, because we have become animal now, listen now. अब हम लोग किसी का बर्दाश्त नहीं करते, तुरंत फैसला करते हैं, ठीक है. You see what is happening, right, happening across the world, right. You see in Middle East, you see in, right, see Europe, क्या हो रहा है, चारों तरफ एक चलने वाला है, ठीक है. तो ऐसा माना जाता है कि जो हम लोग का आज करंट बिहेवियर है उसके हिसाब से we are not going to last, that means the last branch of this Homo sapien is not going to last, right, last beyond 1000 to 2000 years, ठीक है. उसके बाद फिर से इवोल्यूशन होगा, हो सकता है कोई रोबोट बन के आ जाए, ठीक है ना, कुछ भी ऐसा हो सकता है ना. तो ये ध्यान रखना है कि the evolution of continental crust has undergone 3 phases, or shall I say it has evolved under 3 phases: microplate tectonics, classical plate tectonics, and then you have modern plate tectonics. Maximum gain in land mass has been witnessed during modern plate tectonics. You can highlight the example, you can talk about Alps, you can talk about Himalaya, you can highlight the example of Rockies, Andes. These all mountains are example of what? They're example of gaining mass to the land area at the expanse of oceanic crust. ठीक है? Yes or no? बात समझ में आ रहा है ना? तो ऐसा हम लोग देखो, ऐसा हम लोग मानते हैं ना, प्लेट टेक्टोनिक्स जब पढ़े तो आपको समझ में आएगा कि right, you know that the convergent boundaries, right? You see the convergent boundaries are shorter than the divergent boundary, ठीक है? Right? So actually what should happen along the divergent boundary, right? You have the formation of newer and newer crust, right? And along the convergent boundary, what happens? One of the plate which is denser is destroyed, right? Or destruction होता है उसका, ठीक है? But still, we do not have any evidence to prove the fact that the crust is right. The crust, that means the earth crust is increasing in mass, or so it is decreasing. It is having a perfect balance, right? That means at one place where the oceanic plate is being destroyed under the continental plate, at some other location, newer and newer oceanic crust is being formed. बात समझ में आ रहा है? This is how the balance is made, right? As far as the continental crust is concerned, continental crust are different from the oceanic crust. सबसे पहला उनका जो डिफरेंस है यही बात है कि they cannot be recycled back, ठीक है? They cannot be pulled back, right? They are lighter and they are buoyant crust, ठीक है? They are crust which follow the law of flotation, or you can say the force of buoyancy, ठीक है? They will always remain buoyant. That is why they are growing in size at the expanse of the oceanic crust, ठीक है? ठीक है. और यही मैं बोल रहा हूँ कि आने वाले समय में भी, ठीक है, आज से 500 मिलियन ईयर्स हो, मतलब आप कंक्लूजन में ये सारा कुछ लिख सकते हो, ठीक है. आने वाले समय में भी this trend is going to continue and there will be further increase in the land area, right? And that increase in the land area would be at the expanse of what? Would be at the expanse of the oceanic crust, ठीक है. तो जितने भी oceanic crust है उसका रिसाइकलिंग होने लगेगा. देखो आपको ये भी पता होगा, the oldest dated rock I said is found where? मैंने बोला oldest dated rock कहाँ मिलता है? That is found over the land. Yes, which also means that the continental crust is the oldest one, right? And nowhere the oceanic crust is older than 200 million years. ठीक है? मतलब we have dated the rocks. ठीक है? We have dated the rocks from continental crust and oceanic crust, and it has been found that the youngest of the rocks are found where? Over the oceanic crust, right? Which confirms to the fact that the oceanic crust are always undergoing recycling. ठीक है? नहीं तो आपको फिर से ये कंफ्यूजिंग लगेगा कि प्रिमिटिव क्रस्ट तो बन गया था, वो तो ओशनिक क्रस्ट था, ठीक है ना? तो ओल्डेस्ट उसी को होना चाहिए, पर वो ओल्डेस्ट नहीं है, बिकॉज दैट हैज बीन रिसाइक्लेड, राइट? आर यू गेटिंग माय पॉइंट? दैट इज व्हाई the oldest dated rock is now found over the ocean, right? कहीं भी दुनिया में कहीं भी जो ओशन क्रस्ट है वहां पे रॉक 200 मिलियन ईयर से पुराना नहीं मिलता, ठीक है? और हम जो रॉक देखते हैं लैंड एरिया पे वो कैसा है? that is having, or so that dates back to almost 4.1 million years. That confirms the fact that the oceanic crusts are always undergoing recycling. हमेशा recycling चल रहा है, ठीक है? One more thing I want to highlight here. Like when you talk about those cretins, ना cretins है तो क्या एग्जांपल है, आपको क्या पता चलता है? अब इंडिया का एग्जांपल ले लो, ठीक है? You see this one. Can you see the brown part here? ठीक है? You have these parts, like you have Chota Nagpur plateau, right? Karnataka plateau, Tamil Nadu, Shillong plateau. These all are what? These all are representing the oldest block of the earth, oldest block, right? ठीक है, ये सारे क्या है, क्रेटेंस है, राइट। दैट मींस जो अभी मैंने यहाँ पे आपको बताया ना, केटोलैंड, राइट, कोलंबिया, राइट, योर रोडिनिया, राइट, ये सारे जो सुपर कॉन्टिनेंट बने हैं उनका रॉक्स मिलता है हमको कहाँ पे, इंडिया में, ठीक है, राइट फ्रॉम अरावलीज टू, राइट, अच्छा, Aravallis to your Shillong plateau, to your Chota Nagpur plateau, to your, right, to your Karnataka plateau, you will find oldest of the rocks here, right? ठीक है, आप लोग पढ़ेंगे उसको, धारवाड़ rock formation, you'll come to know about this, right? They are the oldest block, right? Oldest rock, and these rocks have been found in India also, which confirms that initially these were, right? These were what? These were small, right? Small, I said small continental nuclei having two structure, one sealed, the other was platform. Platform is nothing but the geosyncline. That's it, right? Shallow depth of water zone. Okay, we'll discuss about that. Geosyncline is a topic, separate topic under geomorphology. So these are the things you have to keep in mind when you deal with this topic of origin and evolution of Earth crust. Just because you have completed this topic, so I'll give you one practice question over this topic. Please write one question and attempt it. हालांकि आंसर राइटिंग अभी से शुरू नहीं करना है मुझे, ठीक है, मैंने आपको बताया कि आप लगभग 10 दिन के बाद हम लोग शुरू करेंगे, ठीक है। That means answer writing session in the class. Okay. So here you can practice and see, right, whether you are able to write an answer or not, ठीक है। So take one question. Discuss the phases and processes. Discuss the phases and processes involved in the origin and evolution of the earth crust. Phases and processes, ठीक है। 15 मार्क 250 वर्ड्स। अगर मैं इसको 10 मार्क का कर दूंगा तो आपके लिए तकलीफ बहुत हो जाएगा, ठीक है ना, क्योंकि आप क्या करने वाला मुझे मालूम है। आप पूरा का पूरा स्टोरी यहाँ पे, you will be just reproducing the story, right, without understanding the real demand here, ठीक है। सारा स्टोरी यहाँ नहीं लिख सकते हैं, है ना। क्या लिखना है आपको, देखिए मैंने बोला 15 मार्क्स 250 वर्ड्स, है ना। तो you have to talk about two things here. One is phase and the second is process. Yes, phase and process. Okay. Now when you talk about the phases, so you have to talk about the phase of the earth, right, from the gaseous state to liquid state, and then come into the solid state. Yes. And what you have to talk about? You have to talk about those processes, right? Along with that is density differentiation, magnetic differentiation, or chemical differentiation. You have dealt with the process, ठीक है। Avoid talking about the events. अगर events के ऊपर बात करने लगे तो मुश्किल हो जाएगा, ठीक है। बात समझ में आ रहा है? Event मतलब अगर आप एटमॉस्फेयर का इवोल्यूशन का ऊपर बात करेंगे तो that will take 100 words, right? You just have to highlight the event कि event ये हो गया, ठीक है, right? So these are the phases, and then after completing the origin, you know what you have to do? You have to talk about the evolution, right? That means micro, classical, and modern plate tectonics. Clear? Processes को भूलना नहीं है, and processes will those processes will operate in different phases, right, from the microplate tectonics to classical, and finally in the modern plate tectonics also. Processes मतलब आपको क्या करना है, convergent, divergent, दो ही बात करना है, ठीक है। Yes or no? So this is what you have to focus on. Avoid talking about the events. जो मैंने इतना डिटेल आपको बताया, अब ये बोवेन रिएक्शन सीरीज आप बताने लगो तो फायदा नहीं है, ठीक है? आप पूरा पेरिडोटाइट, ना ओलिवाइन, पैरोक्सिन ये सब बोलने लगे तो हो गया, आपका कल्याण हो गया, ठीक है? That is not the demand here. The demand is what? Talk about the phases and the processes. That's it, right? Talk about the major phases, ठीक है? तो गैसेस स्टेट, लिक्विड स्टेट, और वही पे रुक जाओ. वहां पे पूरा क्या बात करना है? चर्निंग, रिसाइक्लिंग, यस, this one separation of lighter material from the denser one, right? Formation of those right, those, you know, crystallization of those minerals right from the denser mineral in the lower part to the lighter material in the upper part, ठीक है? Again the primitive crust is being formed. The primitive crust is subjected to bombardment by meteorites and sand that is being also ruptured by the convective current, that means the hot magma rising up, yes, and again that is being recycled back, ठीक है? This material which is being subjected deep inside the earth undergoes partial melting हो रहा है, again magma is forming, again the magma is rising up, ये process चलता जा रहा है, ठीक है ना? और वो फिर फाइनली क्या होगा? You have formation of basaltic crust. Once that basaltic crust is formed, then you can briefly refer to what? Just talk about one sentence, right? उससे ज्यादा नहीं बोलना है, ठीक है? Secondary atmosphere led to what? Or the formation of secondary atmosphere led to heavy and continuous rainfall for 40,000 years, and when that magma came in contact with water on the surface of earth, that underwent chemical differentiation and sand developed into what? Developed into granitic rocks, right? The part of the granitic rock which came above the water, that became continental nuclei, and then you talk about the what? Then you talk about the processes for evolution, ठीक है? Increase in the size of the land, ठीक है? Continental nuclei तो बन गया, बहुत छोटे हैं, ठीक है? माइक्रो है ना? और वो लैंड एरिया लगभग 2 से 3% की है ना? तो कैसे ये इतना बढ़ता गया? And how it has reached up to 29.2%. Use those examples, right? Talk about microplate tectonics, ठीक है? थोड़ा वो सब बता दीजिए, और यहाँ पे ऐसे आपको कवर करना. अगर एक क्वेश्चन को मैं बदल दूंगा, ठीक है, और इसमें बोलूंगा डिस्कस द मेजर इवेंट्स दैट हैव लेड टू द ओरिजिन एंड इवोल्यूशन ऑफ मेजर इवेंट्स, राइट? Then you have to talk about those events which has taken place, right, internally and externally. दोनों बात करना पड़ेगा आपको. और इवेंट्स में प्रोसेस के ऊपर ज्यादा फोकस नहीं करके हम लोग क्या करेंगे? We'll mainly talk about the timeline, ठीक है? क्या क्या हो रहा है? इवेंट मतलब टाइम होता है, ठीक है? टाइम में आपको दिखाना पड़ेगा कि क्या क्या चल रहा है, ठीक है? So this is one question I would request all of you to attempt this, ठीक है? एक बार attempt कीजिए. So now we have completed the first topic, and we'll move to the next topic in sequence, that is physical condition inside the earth. See the fifth topic of the syllabus. टॉपिक देखा आपने, क्या है? फिजिकल कंडीशन इन द अर्थ इंटीरियर, यही है ना, ठीक है? तो दिस इज व्हाट वी हैव टू स्टडी नेक्स्ट, ठीक है? एंड एंड व्हाटएवर डिस्कशन वी हैव फॉलोड, कीप इन माइंड, whatever discussion we have followed, that has helped us in understanding the evolution of the earth interior, ठीक है? अर्थ इंटीरियर का evolution हो गया, but that was not the complete story, because we were more interested in earth crust rather than earth interior, right? So we focused more on the earth crust, that means the evolution of oceanic crust and the continental crust. It was mainly the evolution of the continental crust, because origin and evolution of oceanic crust is easy to understand, okay? So now we are going towards one zone of comprehensive study of the earth interior, right? Comprehensive study, right? The whole body of the earth, not only one zone, ठीक है? अभी तक हम लोग क्या देखा? We just referred to one zone of the earth interior, that was your earth crust, ठीक है? अब हम लोग क्या देखने वाले हैं? We are going to see the entire body, right? Where we'll have all those broad layers inside the earth. You know that, right? You have 3 broad layers, that is crust, mantle and core, right? And our focus will remain where? Our focus will remain on the physical conditions, ठीक है? And when I say physical condition, you have to refer to three geophysical, right? Geophysical phenomena. What are those three geophysical phenomena? That is temperature, density and pressure. ठीक है? ये तीनों बात को हमको ज़्यादा फोकस करना है. ठीक है? And that will give answer to all our questions related to Earth interior, right? When I say Earth interior, that means, right? Why the inner core is in super solid state? Why the outer core is in liquid state? Why that asthenosphere or that LVZ, जिसको हम LVZ भी बोलते हैं, low velocity zone, right? So why that asthenosphere is in semi-liquid state, right? So to solve this mystery, we have to depend upon what? We have to depend upon three geophysical phenomena, that is pressure, temperature and density. Okay? Right? But before that, let us understand the handicaps which we have in the study of Earth interior. क्या problem है? ठीक है? Why study of Earth interior is not easy? ठीक है? Why it is always mysterious? Okay? Why we are not able to understand the Earth interior perfectly? There are reasons for it. Okay? What are the reasons? Number one, अभी याद रखना मैंने शेप भी नहीं बताया अर्थ का क्या शेप होता है. ठीक है? ये सब सारा बात हम लोग क्लाइमेटोलॉजी में शुरू करेंगे. ठीक है? So here, right, I am taking a spherical shape of the Earth, right? Spherical shape of the Earth, and you know the radius of the Earth is 6371 kilometer approximately. ये हमारा रेडियस है, right? So this is your Earth interior, and as I said to you that the study of Earth interior has always remained under a mysterious, a mysterious condition, or it has always been surrounded by mysteries, mysteries and it is more I would say the knowledge and understanding about the Earth interior is mainly a product of generalization rather than having any direct contact with the Earth interior, direct observation of those phenomena. Okay, so Earth interior is not the study of the Earth interior is not I would say it is not easy just because the Earth interior is not open for direct observation, right? We cannot establish direct contact with the Earth interior because the condition prevailing inside the Earth is very tough, right? You have extreme condition prevailing inside the Earth. We talk about temperature, very high temperature inside the Earth. Number two, you have very high pressure condition inside the Earth, and I'm talking about which temperature, which pressure. I'm talking about geotemperature and geopressure, right? Okay, forget about air pressure. अभी एटमॉस्फेयर में हम नहीं गए, हम लोग अर्थ के अंदर जा रहे हैं, ठीक है? So this is your interior of Earth, which has always remained mysterious for us because the interior of Earth is not open for direct observation, ठीक है? That is not available for direct contact. हम direct contact नहीं कर सकते, ठीक Okay. The deepest point up to which we have made direct contact with the earth interior is 12 kilometer, right? 12 kilometer up to which we have drilled the crust and we have collected rocks, right? We have collected those rocks. Those rocks are sent to the laboratories, and what we do, we study, right? We study two aspects of the rock. One is physical aspect, the second is chemical aspect. That means the physical property and the chemical property, right? When we talk about the physical property, we see whether the rock is elastic rock or not, right? Whether the rock is a brittle rock or that means weak rock, okay? Or when we talk about the chemical property, we focus on the chemical composition of the rock, right? Do we have high proportion of silica, high proportion of magnesium, or we have high iron content? Yes or no? That is your chemical, right? Chemical composition of the rock, okay? So again, right? Again, this deep sea drilling is one project which is not for, right? Which is not which is not designed, right, designed to study the earth interior, but actually this is a commercial project, right? One economic project where those equipments are used to extract those precious mineral oil and natural gas from the rock bed, right? And they develop those techniques, those drills, right? That means those earth cutters. They have those techniques which can drill up to the depth of 12 kilometers. And through those drillings, we have collected the rocks and we have studied them. Okay. So this much we have made direct contact with the earth interior. Okay. Apart from that, the direct contact the human beings have made to the earth interior is only 3 to 4 kilometers, right? Which is the deepest mine we have in South Africa. You know that the deepest of the mine in the world are gold mines and डायमंड माइंस, ठीक है? सबसे ज्यादा जो डीपेस्ट होता है कोल माइन जो होते हैं, कोल पता होगा, कोल जो है वो डीप माइनिंग नहीं होता, ठीक है? मैक्सिमम आई वुड से आजकल तो यू हैव ओपन कास्ट माइनिंग, राइट? वेरी कॉमन नाउअडेज. वी डू नॉट गो फॉर टनल माइनिंग. अब टनल माइनिंग नहीं करते, ठीक है? मतलब हम लोग अब टनल नहीं बनाते. अब हम लोग क्या करते हैं, ऊपर से ही खोद के क्या करते हैं, डेब्रिस हटाते हैं, सेडिमेंट्री लेयर हटा के अंदर से कोयला निकाला और फिर उसको ऐसे छोड़ देते. दैट इज कॉल्ड ओपन कास्ट माइनिंग, राइट? ओपन कास्ट माइनिंग. So that is your coal which is found at a relatively lower depth, whereas gold, diamond जितने precious mineral है वो और depth में मिलते हैं, ठीक है ना? आपने तो वो मूवी देखा होगा ना जिसका क्या नाम था, KGF. अरे सुनो, KGF 1, KGF 2, ठीक है? आजकल लोग इसी से बहुत इम्प्रेस हो जाते हैं कि नहीं? तो KGF है क्या? कोलर गोल्ड फील्ड, यस, है ना? और मालूम है आपको कोलार, हुट्टी, these are famous gold mines in our country, located in Karnataka. They are part of Dharwad rock system, ठीक है? तो ये हमारा deepest contact है, ठीक है? जब माइनर्स नीचे जाते तो वो क्या देखते हैं? When they go deep inside the earth, they experience high temperature condition, warm, ठीक है? Warm लगता है उनको, ठीक है? जैसे मान लो आज सर्दी है, आप माइनर्स हो, ठीक है? माइनर हो, आप कोल माइनिंग करने के लिए नीचे जा रहे हैं टनल से, तो आपको नीचे क्या होगा, गर्मी का एहसास होने लगेगा, ढेर सारा कपड़ा फेंकना पड़ेगा, पसीना होने लगेगा, ठीक है? तो इससे क्या आपको क्या समझ में आया कि as we go deep inside the temperature increases, right? They collect the material. जैसे हम surface से शुरू करते हैं, we see the soil, right? We see the sedimentary rock, and as we proceed deeper, we find the rocks which are having higher density. और ये हमको क्या कंक्लूड करने के लिए हेल्प कर रहे हैं? We are able to conclude that the density too increases with increasing depth, ठीक है? अब जब नीचे जाते हैं तो उनको क्या महसूस होता है? उनको प्रेशर लग रहा है कि सर के ऊपर कुछ गिरने वाला है, ठीक है? राइट? They are experiencing high pressure, okay, which is not the case when you are on the surface of Earth. We have atmosphere, but we do not feel that much of pressure, right? So when you go into the tunnel, you feel the pressure of the overlying rock strata, right? जो ऊपर है, आप टनल से जा रहे हो, ऊपर में क्या है, रॉक्स है, नीचे आप जाते जा रहे हो, ठीक है? आपको ऐसा लगा कि अब ऊपर से कुछ प्रेशर है, ठीक है ना? इससे हम लोगों ने क्या कंक्लूजन किया कि प्रेशर भी इंक्रीज होता है, ठीक है? राइट? So these are the limited observation we have, limited observation we have with respect to the earth interior, and these direct observations are negligible in the context of the dimension of the earth interior. You know what is the dimension? I said radius of the earth is 6371 kilometer approximately, ठीक है ना? तो इतना मतलब इतना डायरेक्ट कांटेक्ट 3-4 किलोमीटर तक हमारा कोई फायदे का नहीं है, वो इट कैनॉट टेल अस द फुल स्टोरी ऑफ द अर्थ इंटीरियर, राइट? So that is why, right, that is why these you know, direct observation are of negligible importance, right? They are of least importance because they do not tell us the whole story of the earth interior. Okay, clear? Now coming to the next point, you know the deepest pipeline. जो हमारा deepest pipeline है दुनिया में वो कितना है? That is 8 kilometer. That is found in South Africa. ठीक है ना? Pipeline हम लोगों ने बिछाया. That is a gas pipeline, right? 8 kilometer deep. Okay. So these are the points up to which we have made. That means एक ही बात याद रखना है. इतना लंबा स्टोरी करने की जरूरत नहीं है. ये तो बस मैं पढ़ा रहा हूँ इसलिए इतना कुछ बोल रहा हूँ. तो आपको ध्यान रखना है कि 12 किलोमीटर का डेप्थ है जहां तक हम लोगों ने ड्रिल किया हुआ है, ठीक है? उसके बियॉन्ड हम लोग नहीं जानते कि क्या होता है नहीं होता है, वी डू नॉट हैव डायरेक्ट कांटेक्ट, ठीक है? और 12 किलोमीटर में जो ड्रिलिंग किया वहां पे आदमी नहीं गया, मशीन गया हुआ है, ठीक है? और मशीन क्या कलेक्ट करके ला रहा है? रॉक्स कलेक्ट करके ला रहा है. उसको हम लोग क्या कर रहे हैं? हम लोग लैबोरेटरी में स्टडी कर रहे हैं, दैट्स इट, ठीक है? तो दिस इज वन पॉइंट यू शुड कीप इन माइंड, ओके? You must be aware of one I would say over ambitious project which was launched by the international community, having a community of nation. India was also one of the member of that project called Hadron Collider project. ठीक है? That was launched in the year 2002 in France. ठीक है? France में ये मिशन स्टार्ट किया गया, प्रोजेक्ट पे काम शुरू हुआ. And then there was a timeline fixed under the mission to drill the earth from one end to the other. क्या करना है? मतलब देखो दिमाग क्या कर रहा है? अर्थ को इधर से ड्रिल करो और इधर निकालो, ठीक है? एक होल बनाना है, ठीक है? And what we'll do after creating that hole inside the earth, we'll send rovers. जैसे हम सैटेलाइट को भेजते हैं ना, रोवर्स को मून पे, मार्स पे, है ना? हम लोग दुनिया जहां का हमारे पास इंफॉर्मेशन है, लेकिन अंदर अर्थ के बारे में ही हम लोग को कुछ पता नहीं, ठीक है? So we wanted to have a drilled hole from one end to the other so that we can send our rovers, and the rovers with high resolution camera, they would be able to take snaps, that means those images, and they would be sending those images and we'll be studying those images, and that will give us a better idea about the earth interior, ठीक है? लगभग 4 साल काम हुआ इस पे. 4 साल के बाद निकला क्या? कुछ नहीं. Why? Because there is no known substance in the world which can withstand the temperature prevailing inside the earth. ठीक है? रोवर को बनाओगे किससे आप? You need metal, right? You need those elements which can sustain high temperature conditions. And there is no known substance in the world which can withstand a temperature of more than 3000 degrees Celsius, right? And the prevailing temperature inside the earth the average temperature is 6000 degrees Celsius. तो क्या किया हम लोगों ने? 4 साल के बाद हम लोगों ने वो मिशन को ड्रॉप कर दिया, ठीक है? It is not a possibility for us, right? That means direct contact cannot be established with the earth interior. Okay, clear? So then in that case, what we should do? From where we should get the clue? कहाँ से clue लाए हम लोग? ठीक है? What should be the clue that will help us in understanding the earth interior, or at least developing a general understanding of the earth interior? So there are sources which help us in reconstructing the behavior of earth interior. They help us in sharing some information about the earth interior, and those sources are basically divided into 2 groups. Those sources are divided into 2 groups: direct sources and you have indirect sources. Direct sources, number 1, we have already seen that deep sea drilling project. And what it does, I have explained that. Second is volcanic eruption. Under indirect sources, we have these sources like the measurement of temperature, density, and pressure. Then the study of meteorites, gravity anomaly, magnetic survey, and the last one, the most important one, is your seismic waves. That is the most important one, the most reliable source, right? The most reliable source, okay, which tell us, right, which tell us complete story of Earth interior, ठीक है? और याद रखना कि जो ये sources है क्या करते हैं? They just tell us the what part of Earth interior, केवल what बताते हैं, ठीक है? They cannot tell us, right, tell us the why part, ठीक है? Why part नहीं बताते, ठीक है? That means why the Earth interior is behaving the way it is behaving is not explained by, right, is not explained by these sources. These sources only share information. इसलिए मैंने लिख दिया है, right? Sources sharing information about the Earth interior, only information, right? We only get knowledge about the Earth interior, okay? But the behavior of Earth interior is understood by taking into account the three geophysical phenomena, that is temperature, density, and pressure condition. Okay, we'll talk about that. So deep sea drilling, I have already discussed this. Okay, volcanic eruption. Now by seeing volcanic eruption, I said by seeing volcanic eruption, we can say we can be misled. We can misled, right? We can be misled that the Earth interior is in molten state. Right? You see volcanic eruption, what comes out? You have magma coming out, right? By seeing that magma, the superheated material coming out from the cone of the volcano, we conclude that the Earth is the Earth is what? The Earth is in molten state. But actually, what is the fact? What is the fact? You know that the Earth is not in the molten state, right? So volcanic eruption helps us in understanding the material composition of the Earth interior, but it does not tell us the full story because by observing the volcano, we may be misled to understand or conclude that the Earth interior is in molten state. But actually, we know that Earth interior is in solid state, right? Only one layer is in liquid state, and that is your outer core. Yes, ठीक है? बात समझ में आ रहा है? तो they have a limited importance, limited, ठीक है? ये पूरा कहानी नहीं बताते, clear? Now come to indirect sources. Temperature, density, pressure. जो मैंने बताया आपको, ठीक है? We have done that measurement. We have calculated the behavior of temperature, pressure, and density on the basis of those direct observations, shared by the miners, right? And we say that temperature has increasing trend, density has increasing trend, pressure also increases with increasing trend. Very good, right? Very good. But the point is, if you follow these three geophysical phenomena, again they will not be able to tell the full story because you know the relationship between them. What is the ideal relationship? You tell me, high temperature leads to high density or low density? High temperature will lead to high density or low density?
High density.
High density? अच्छा कोई बात नहीं, एक काम करते हैं, कुछ भी ले लो, ठीक है? You hit something, you hit an object. Right? Heat an object. What happens to the object now? The object undergoes melting. Are yes or no? Are yes or no? ठीक है. Solid को आपने अगर heat किया वो melt हो जाएगा molten state में. So what will happen to that molten state of that object now? Decrease in the density or increase in density? Decrease in density. High temperature leads to decrease in density. The intermolecular space will increase, my friend. Okay? अगर temperature बढ़ता है तो. But actually क्या हो रहा है? You know that temperature increases inside the density too increases, which means that temperature does not tell us the full story, right? It is not giving us a correct story, right? It also confirms that the density of the substance inside the earth is not controlled by temperature, but it is controlled by pressure. ठीक है? फिर से कहानी पूरा नहीं बताते, ठीक है? Coming to the meteorites को भी हम स्टडी करते हैं. क्या देखते हैं उनको? you know that meteorites, Earth, these all celestial bodies have evolved from the same parent matter, right? Okay, so we study their chemical composition and we see their surface. जब उनको surface पे देखते हैं, उनका structure देखते हैं, and as we see the surface, we find what? We find those minerals like iron, calcium. ठीक है? You'll find high proportion of magnesium, right? But in the case of Earth, what is the pattern of distribution of those minerals? You know that the densest of the mineral inside the Earth is not found on the surface of Earth, but where? In the innermost part of the Earth interior. ठीक है? तो meteorites भी हमको पूरा कहानी नहीं बता रहे, वो भी हमारे काम के लिए। Gravity anomaly. Gravity anomaly का मतलब क्या हुआ? We do not have same gravitational pull everywhere on the surface of Earth, right? Or yes or no? You must be knowing that the highest pull is observed where? Near the pole, and you have low gravitational pull near the equator. Okay? And why this is so? This is just because of the circumference of the Earth interior. Okay? Circumference बड़ा है, ठीक है? And that also confirms to the point that there is unequal distribution of mass, right? Mass inside the Earth. That means some zones are having compressed existence of material, and some zones are having exfoliated or expanded nature of material distribution, right? And that is why the gravity is found to be different from one place to the other. Okay? But again, the gravity anomaly cannot tell us about the distribution of material, right? Do we have large concentration of material in the polar area, right? Large concentration, no. Highest concentration of material you find in the equatorial belt. But the equatorial belt is having what? The equatorial belt is having concentration of lighter material, right? Whereas the polar areas are having concentration of denser material, right? Magnetic survey क्या होता है? Simple सा समझना है. That is one survey we do at the surface, and then we refer to two kinds of surface. That is your continental block, and the second is your oceanic block. ठीक है? Right? So magnetic survey helps us in understanding the density of the density and the mineral composition of the crust by following one simple exercise. जैसे कि मान लो ये land area और ये water surface है. Always we have to take land area above the oceanic crust. ठीक है? Oceanic crust और ये हमारा land area है. तो if you allow an iron ball, मान लो एक छोटा सा iron ball ले लो, मालूम है gravity तो earth interior is acting like a magnetic bar. तो you leave one iron ball, and let it fall freely. ठीक है? Let it fall freely on the land area. What happens? The iron ball falls, no doubt, right? But it falls with a lesser velocity in comparison to the iron ball being dropped over the oceanic crust. Okay? If you drop one iron ball over the oceanic crust has greater intensity of absorbing or pulling that iron ball towards it. That confirms that the oceanic crust is made up of what? It is made up of ferrous mineral, whereas the oceanic crust is made up of, or the continental crust is made up of sialic material. You will not find iron. And what you find in the basaltic crust, मालूम है ना? Basaltic crust will have magma, which is rich in magnesium, which is rich in iron, and it has little bit of silica. ठीक है? बस इतना ही बात आपको समझना है कि मैग्नेटिक सर्वे का मतलब हो गया कि हम ये पता करते हैं कि इसका केमिकल कॉम्पोजिशन ज्यादा है, मतलब केमिकल कॉम्पोजिशन किसमें आयरन ज्यादा है, और दूसरा हम पता करते हैं कि मास किसका ज्यादा है. तो मास किसका ज्यादा होगा? ऑब्वियसली ओशनिक क्रस्ट का, बिकॉज़ दैट इज डेंसर, एंड कॉन्टिनेंटल क्रस्ट इज लाइटर. ठीक है? लाइटर. बात समझ में आ रहा है? तो this is what we see as magnetic survey, but again that is not going to tell us the full story. क्यों? Because that is only limited to the Earth's surface, not about the Earth interior. What is happening inside the Earth cannot be shared by magnetic surface, right? They help us in understanding the difference in the property of continental crust and oceanic crust. Continental crust are having lighter property. They are non-ferrous, so the iron ball falls freely, but with lesser velocity. Whereas the same iron ball, left freely over the oceanic crust falls with greater velocity, because the oceanic crust is made up of ferrous mineral. Okay? This is what you have to keep in mind. Clear? So we'll see the seismic waves tomorrow, right? These are the indirect sources you have to keep in mind, and whatever knowledge we have, right? We have about the earth interior. That comes from, right? That comes from the study of the seismic waves. Okay. So tomorrow we'll start with seismic wave and we'll see the rest part of the interior of the earth. Thank you.